2024 USAMO JMO mock test problems. There are 6 problems. Problem 1, 2, 3 for day 1 and problem 4, 5, 6. Some problems are from PMO. And you can use the time codes in the description to go straight forward to the solution of the problem you want. Here we'll be considering important ideas that are useful also in USAMO JMO. If you want to learn other ideas, feel free to send message to my WhatsApp number in the description. Try problem 6 functional equation first on your own, okay? And let me know if you wanted hint.
Okay. Oh, just had a question. Is there more than one answer for this?
Maybe I don't remember one answer or more. So you found one answer,
I got f of x is x.
but you couldn't prove that it is only f of x, right?
Yeah.
Want hint?
Yeah, could you give him?
Okay, so we have complicated term, right? For example, f of x minus f of y, right?
Yeah.
This part.
Do you?
Maybe first we can check to get rid of this. Also, other thing that you should do is to check f is 1 to 1. Okay, I remember f was 1 to 1. So you should prove f is
Right.
1 to 1 and you can use it to, for example, reach some good result. One more hint or that's enough?
That's enough.
Okay.
Oh, wait. 1 to 1. To prove that it's 1 to 1, do you show that like f of a equals something, f of b equals that something, and then a, and prove by contradiction?
No, you say f of
a
a is equal to f of b, then you should prove that a is equal to b.
Okay.
Okay, you should try this. Okay, try. One hint?
I'll keep trying. I was able to prove 1 to 1.
Yes, you should use that to reach some good result because when f is 1 to 1, when f of something is equal to f of something, you can cancel f, right?
Yeah.
Okay, so wanna keep trying? Or one hint?
Yeah, I'll keep.
Okay, sure.
Actually, could you give a bit of it?
Okay, sure. So, how you prove that it is 1 to 1?
No. I was able to get. Oh. How was it? Oh, cause I got this. Oh wait, sorry. Zero. Oh, I substituted x as 0,
Mm-hmm.
and then I got this formula that was like f of 2 of f of 0 equals f of negative f of y plus f of 0 plus y.
Mm-hmm.
And then I said that this means f of negative f of y is equal to negative y plus some constant k, because the other two terms are just constant. And so I used that, and then I did the assumption f of a is f of b. I substituted y equals a, and I was able to prove y equals a, y equals b, and they were
exactly. So minus f of 0 plus minus y. So you say when f of a is equal to f of b, if you replace right hand side equal negative a negative b and a equals b, right? Okay, now let's see what can we say. You found f of this part is equal to this part. Now here, can we get rid of these terms? For example, it is x minus f of y, it is y plus f of x, right? So, for example, if you consider special cases or something like that. For example, if we say x is equal to f of y, then what can we say? F of,
Won't be worse because it's 2f of y.
yes, this part will be bad, right? This part will be good, f of 0, right? Plus f of y plus y. Okay, one thing like this. Now, uh, what else can we say? If, for example, can we reach any other good result? If x is equal to y, for example, or let's cancel this part. In this case, I try to cancel this, right? Now let's try to cancel this. So y should be equal to what?
Y should be equal to, oh, like,
Yes, if I want to cancel this. Yes, and why it is good? Because then these two f's are equal. I can cancel f's because they are 1 to 1, right?
Yeah.
So, in this case, f of 2, f of x is equal to what?
F of x minus f of negative f of x equals 0 plus 0. So
Yes, so we can cancel these two things, right?
right.
So 2f of x is equal to x minus f of negative f of x, right? So, here we can say that let's consider f of, for example, x. Okay, so let's draw something around this. We know this one. Good results. F is 1 to 1, right? Okay. Now from this part that we know f of negative f of x plus 2f of x is equal to x, right?
Right.
So we can see that can we use this part or not? Want to try rest on your own? One more hint.
Can you give more hint? Because I reached, I wasn't sure what to do with the.
Okay, sure. So here there are real numbers. If we check, for example, f of 0, can we say any good thing?
F of 0? Oh, because it'll be 2f of 0 is negative f of negative f of 0.
Yes. Here, if we replace, so let's do something. Here we cancel this one, we reach this result, right?
Yes.
Then we wanted
Oh,
to
if you
cancel
cancel.
this, what? If we cancel
Oh,
it,
sorry. Oh, the 2f of x.
what do you mean by 12 of x?
Like the f of 2 of x. F of 2f of x. Would it
On
be
this
useful to
part,
cancel? Yeah.
we can, yes, for example, we have these, we can use x and, for example, w, something like this, right? And then, for example, write it twice. So let's see.
Right.
For example, f of 2f of w is equal to f of, or let's do something, f of x and w.
Negative what?
F of
Right.
x
Oh, okay.
minus f of, for example, w, right? Plus f of x plus w, right? Then if we know left hand sides are equal, so right hand sides are equal. So you can cancel f of x. So f of x minus f of y plus y is equal to f of x minus f of w plus w, right? So if you consider, one thing was this, that we've considered this part. Also we found that f of negative f of x is this. So let's do something. Because we found a formula for this, if you replace x with 0, we can use that, right?
Right.
Okay, so for f of 0, you said this. Agreed?
Yeah.
So let's combine this with our previous result, okay? So let me place it here. Like if we replace this part, we know f of negative f of y is what? By this one by 1.
2f of y. No, y minus 2f of y.
So that's so much good result. Because then it is a constant. And we found f of y in terms of y, right? Y minus 2f of y is equal to f of 2f of 0 minus. So when you reach any good result, try to number them, for example, from here. 1, for example, 2, 3, and it's better to write them in order. So let's write this one, for example, 1, this one 2, this one 3, okay? And the rest I think is not hard. Want to try the rest or want more hint?
I'll try.
Okay, sure.
Okay, I think I got it. I proved f of x is x.
Okay. So how?
Oh, so from that last equation, 2f of y became equals 2y minus k. I made the rest k.
Okay, f of y is y plus k, right?
Right.
We can write like this, right?
Okay.
So then you replace in main equation.
Yeah.
Okay.
So it's
So
2y
this
plus 2k.
it's x plus k,
Oh, sorry.
right?
Yeah,
Then
2x
2x
plus
plus
3k.
2k, yes, plus k is equal to this one is y plus k, right?
Yeah.
It's x minus y minus k plus k plus x plus k plus y. So this one minus y 2x
2x
plus 3k is equal
2x
to
plus
k, so 2k is equal to 0, k is equal to 0, right? So f of x is equal to x, right?
right.
And if you replace at the end, we can replace f of x is equal to x. Left hand side is 2f of x. Right hand side is x minus f of x plus f of x plus x. And we know 2x is equal to 2x, right? It's okay. So let's work on 4. Try problem 4 first on your own, okay?
Oh wait, can we go through entire solution?
Oh, okay, sure.
Number 3.
Let me minimize it. Okay. Let's maximize this word first, then that one. Okay, what's the question? Want me to explain again?
Yeah.
Okay, sure. So here the problem says prove that BE, PM, and AC are concurrent, right?
Right.
So then we can use sine law, CY's theorem, and we should prove it is 1. Agreed?
Mm-hmm.
We agree this line, sine A, sine B, P1, P2. Okay. Sine A over B is good, right? So we should focus on P1, P2, and B1, B2, right?
Right.
For P1, P2, we wrote ratio lemma. It is sine C over sine B. Agreed?
Mm-hmm.
For sine B1, B2, I said this angle is B. Why? Because here we see this arc and also this one see same arc, right?
Yeah.
Because this one is B, this one it has to be B, right?
Yes.
Okay, so let me. Okay. So because this one is B, this one is also B. Now, this one is A, so this angle is also A, right?
Right, yeah.
So this angle will be C because two of the angles are BA, it is C, right?
Yeah. Okay.
Okay, for sine B1 over sine B1, B2, we said okay. Whole one is B. Now I want to prove M2 is equal to B2, okay?
Okay.
B2 is alpha, this one is also alpha, agreed? Because they see the same arc, because BMEP is cyclic.
Oh, okay. Yeah.
Okay, because it is like this. And because this line and this line are parallel to each other, so when it is alpha, this one is also alpha, right?
Right. Okay.
So then we can say, okay, M1, B1, B2 is M1, M2, right?
Mm-hmm.
This one. So we can use ratio lemma again here. So it will be this. Agreed?
Right. Yeah.
Okay, so
Yeah.
yes, because sine M1, M2 is dn over PD times sine C over sine A, right?
Right. Yeah.
Now, if you replace here sine A, sine B here, sine P1, P2, we replace it with this, right?
Right. Uh-huh.
We replace it with this one. And for B1, B2, we write this one here, right?
Right.
So we want to prove why it is 1. It is equivalent that y dn over PD is sine B squared sine squared B sine squared C, right?
Right. And then those.
dn over PD by Thay's theorem is x over x plus a, and the rest is the thing here you could prove, right?
Right.
Understood completely, or want me to explain more?
I think I understood.
Okay. Now try problem 4 first on your own, okay?
Okay.
Could you give hints? Your eyesight is bad, and your eyes are blurry.
Oh, is this the minimum, like you less than or equal and greater than equal?
Exactly. You should
Okay.
consider range, right?
Right.
And we should work on both sides, right?
Right.
Have you found any number for one of the sides?
Not yet.
Uh, do you agree that if we use black and white cells are related together, black cells are related together, right?
Oh wait, wait. If you use black and white, so they go to a different color?
Yes, you should only work on white cells. We don't have any problem between different colors. Agreed?
Right.
Or want me to explain? Agreed.
Okay. So
Good.
is we're only gonna use white cells because white cells go to black. So
Let me explain this. Here it says what? Uh, it says to an adjacent in one direction, then jumping. It is knight in chess, right?
mhm.
We then say that a square in a chessboard can be attacked by a knight if the knight can end up on that square after such a move. Then, depending on where a knight is placed, it can attack as many as 8 or maybe even less. In a 10 by 10 chessboard, what is the maximum number of knights that can be placed such that each square on the board can be attacked by at most one knight? Okay,
Right.
so we can conclude. Let me copy and paste a 10 by 10 grid. We can conclude that if we consider knights, the distance of two knights shouldn't be what?
Distance of two knights shouldn't be um
Let me.
two
Yes,
squares.
exactly. Shouldn't be two. Shouldn't be two, right?
Mm-hmm.
So here, let me make it smaller. Smaller. Okay, it is a 10 by. Do you agree if the distance of two of them is 2, for example, like this one and this one? Then, if we have these two, then it is bad because this cell
Okay.
is attacked by two of them.
Yeah.
Do you agree it's bad?
Yeah.
So distance cannot be 2, right?
Mm-hmm.
Okay, now that we found this, another result. If we use black and white, what can we say?
White goes to black, black goes to white.
Exactly. So Do you agree when we have a knight in black cell and when we have a knight in white cell, the distance is what? As a property, the distance, because the colors are different.
Odd.
Odd, exactly. So do you agree when we want to consider, for example, the knights, their distance shouldn't be 2. We don't need to consider black and white because their distance is always odd. We should only consider blacks with each other and whites with each other, right?
Okay.
So do you agree if we find maximum number of knights that we can place in white cells, for black cells it will be exactly same and we should twice that, right? We should double that, right? We should consider twice of that number. Understood or want me to explain?
Understood.
Okay, so in white cells, now which one part is example, right?
Mm-hmm.
And one part is with proof. So we should focus on white cells and see how many knights can we place on white cells such that their distance is not 2, right?
Okay.
Okay, want me to tell you an example or want to find example on your own?
Oh, you can try to find a
Okay, and necessarily your example is not in first try, it's not the best example, but we should work on both proof and example, right?
Right.
Okay, can you tell me if you consider range, or which side is example, left side or right side, and which side is proof?
Right side example, left side proof.
It says maximum or minimum number of nights.
Maximum.
Maximum, right?
Mm-hmm.
So when it is maximum, you said right side. For example, if you find an example with, for example, 30, you prove answer is at most 30 or at least 30.
If you find example 30, it has to be at most 30.
At least 30, because we want answer is maximum. When 30 is possible, answer is 30 or greater than that, maybe we can find a better example, right? So when you find an example with 30, do you agree answer is not less than 30? Because when 30
Right.
is possible, so the answer is maximum of possible cases. So when you find an example with 30, the answer is 30 or greater than that. Agreed?
Mm-hmm.
Okay, and one side is related to proof, okay?
Right. So,
So try to see, for example, you can find what example, then we try a bit on proof, and then we try to reach same number, okay?
mm-hmm.
So one hint for this for want to try on your own?
I'll try.
Okay, sure, try.
Can you give a hint? You can finish picking for yourself, but please, I should already go through
Okay, sure. Your example is what?
Example?
Have you found any example?
Mm, I'm not really sure. I wasn't able
Look,
to get the whole.
because I'm gonna answer at least two. You can find not necessarily best answer, okay? But do you agree you can find a, an example? Let me tell you. For example, do you agree we can place this one here and here, right? Do you agree the distance between these two things is not 2?
Uh-huh.
Agreed?
Right.
But if you place this one, here we have problem or not? No, right?
Okay.
So for example, do you agree we can place these numbers like this?
Okay.
Okay. Now 2, 4, 5. If you don't add any other night from here, the answer is at least what by this example?
5.
5 for whites,
10.
right? Exactly, 10. Now do you agree we can add more? So let's do something. Let's erase all bad cells. Do you agree from here? From here to here, the distance can be 2. This one and this one, right?
Okay.
So do you agree we can remove this, this? And for this one, can
I
we
think it's
add
okay.
this one?
Yeah.
Yes, okay. So answer is at this what now?
Answer is at least 12.
Exactly. Okay. Now, because of this one and this one, we should ignore this, right? The distances too, right? We can ignore
Right.
this, we can ignore this because of this one, we can ignore 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 this one. Agreed on this, right? And
Right.
for this one, you can say this and this, so you can ignore also this part, right?
Yeah.
Similarly, here you can distance, you can remove this one, 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 this one, this one, this one, and here this one, right? Again, from here to here, do you agree we can go here and here? So do you agree we can ignore this, remove this?
Right.
So this one, this one, this one, and these things, right? For this one, do you agree we can go like this and this, right? Agreed,
Right.
we should remove this.
Yeah.
So similarly, we can remove also this one. So you can go here, here. You can remove this one. And also you can go like this and this. You can remove this one, right? And similarly, we can remove this. Okay. But do you agree we can select this one? This one doesn't have any problem. With 2 steps, we cannot reach any of them, right?
Right.
Also, do you agree we can select this one? We cannot reach with 2 steps to these nights, right? So we can say answer is at least what then?
Answer 16.
Exactly. And the answer was 16 or 18, I don't remember one of them. So let's see, can we add, because of this, this part will be removed, 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 this part will be removed. Okay, so again like this. So by this example, we prove answer is at least 16, right?
Right.
Now we want, I think 90% the answer was 16. So we should prove this part, okay?
Okay.
For proving this part, let me tell you a hint. Wow. So let's see something here. Okay. For proving this part, let me see. Do we have 10 by 10 grid chessboard image? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on. Okay. Great. So let me copy a figure. Okay. So now for proving 16, I remember You can also first, for example, you can first focus on proving 18, less than or equal 18, okay? But
Oh.
the way I proved was this. I splitted 1, 2, 3, 4, 5 into 5 parts, okay?
Mhm.
Like this. And then, for example, again, we can focus on only white cells, okay?
Right.
So try to prove in each part how many knights can we have at most, okay? First focus on only these 5 by 5, okay? And for example, when you want to consider these two things, you can use also these cells, right?
Mhm.
So see that in these 5 by 5, how many knights can we have at most in white cells, okay?
Okay.
Okay, try this part first on your own.
I'm getting like something around 20.
Okay, yes, you proved that it is at most 5 for each part, so 4 times 5, 20, right?
Right.
Okay, so we can say the answer is what or what or what?
20, 16, 18, 20.
Exact. So, and let me tell you something. For example, when you reach to this part, if you couldn't solve and for example you didn't have time in the exam, quickly write, for example, your example and your proof for 20, okay? Because if the answer is 16, you will get this mark. If the answer is 20, you will get this mark. And also, if the answer is 18, if your idea is similar, maybe you get some mark, okay? So, at the end, when you say, okay, for example, 10 minutes left, 15 minutes left, and in that time you cannot prove completely, probably. And then quickly, and you don't need to, for example, write neat and nice, write it only quickly and fast, the ideas you've reached, and maybe you can get mark. And let me tell you something. For example, when you reach a good result, write lemma 1, lemma 2, lemma 3. For example, this part that whites and black are not related, lemma 1. And then this part, lemma 2, lemma 3, lemma 4. For example, maybe you reach 6 lemmas in a problem, 6 results. When you couldn't solve it completely, write those 6 lemmas quickly, okay? And the proof of them, and also proof of them, but quickly. Okay, so you proved it is at most 5 for each of them. Can you tell me those 5 are what?
For the it's like the two like diagonal.
Yes. The thing you said is correct. Do you agree if you prove each of them is at most 4, the problem will be solved, right? So, you said 5. Let's do something. If, for example, we select this one, let me copy this. Okay. If we select, for example, this one, do you agree we can ignore this, we can ignore this, we can ignore this, we can ignore this one, this one, this one, this one also, this one, and this one? Do you agree in this case the answer is at most 3? So in this case, this part is at most 3. Agreed?
Oh, why can we ignore the other parts? Are those the
1, 2, no, I said if we select this one, if we have knight here in these cells, we cannot have white knight. Agreed? So if we have a knight here, this part, it is at most 3. Agreed?
right?
Understood or want me to explain more?
Yes, yeah.
Okay, so we can say because of this, let me paste it. We can say we shouldn't select this cell, right?
Okay.
This cell is bad. Okay? And also the agree similarly, this cell is bad.
Okay.
Okay. Now let me copy this part. Okay. If we have, for example, one cell here or one cell here, do you agree that we can, for example, this one, we can remove this, remove this, remove this, remove this, remove this, remove this one, and this one. Do you agree? Again, if we have a cell, if we have knight here, it will be at most 3.
Yeah.
Okay, so again, we can ignore that. And we can remove that, this one, and similarly this one, right?
Mm-hmm.
Okay. Now let me copy this. Okay. If you have a cell, if you have a knight here, let's see, we can remove what's. We can remove this, right?
Right.
Also, we can remove this one. 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 And we can remove this one. So in this case, do you agree if we have a knight here, the answer is at most 1 in this case? So do you agree we can remove also that cell?
Right. Okay.
Okay, let me. Let me think of something. Oh, I have a mistake. Sorry. It is not, we shouldn't prove because when we say 16, then it means that in white cells, we should have at most 8, right? So we should prove each of them at most 2, right?
Yeah.
Okay, so we had this mistake. I suppose we should prove 4, right? So here, when you can have 3 cells, so let me tell you something. But we can say something here. I want to prove each of them will be at most 2. If I prove each of them at most 2, we can prove the problem, right?
Yeah.
So do you agree if we have a cell here, then in these 2 we can have at most 1 knight because they have problem with each other, right?
Right.
So if you have a knight here, in this case it is at most 2, right?
Right.
So we can ignore this one and this one. Then if you have a cell here, again these 2 have a problem, again it is at most 2, right?
Yeah.
Now again we can ignore these things. If you have a cell here, it is at most 1, right?
Yes.
So do you agree that we can ignore this one and similarly this one, right? This one is not similar to this one, okay? Because this one has these outsides, but this one doesn't have this outside, right? This one is exactly similar to this, okay? Okay. Now, if we have, for example, let me copy this one. If we have a knight here, do you agree we can cancel this one because of this? We can cancel this one. We can cancel this one. We can cancel this one. Again, it is at most 2, right?
Right.
Okay. Oh, no, at most 1 we can say, right? Agreed?
Oh.
So again, we can remove this. And similarly, we can remove this one, right?
Mm-hmm.
Okay. Now, if we have here, we can say what? We can say, let me write first one with blue and pink one. You can ignore this one. You can ignore this one. You can ignore this one. Again, at most 1, right?
Mm-hmm.
So you can remove which ones? This one we removed right here. Here also we can remove this one. This one is similar. Oh, we removed this one. We didn't need to check this, right? But we checked. Okay. Now here. So do you agree here you cannot select 3 of them? Because for example this one has problem. So here do you agree it is at most also here this one? Each 2 of them have problem with each other. So at most 1, right? So do you agree we proved that this one is at most 2, right?
Right.
But if I say, okay, 4 times 2, 8, and 8 times 2, 16, Then this proof has a small careless mistake. Can you tell me? We should do one more thing. What?
The arrangement for the other 2 by 2.
Exactly. 5 by 5. This one is similar to this one for white cells, but here we can have 3, right?
Right.
Okay, so here we proved it is at most 2, right? So let's focus on right below 1, okay? So, or let's consider something. Let me erase this part. No. Let me erase this one. Okay. Let's focus on this part. I want to see under what case here we can have 3, okay?
Mhm.
Again, if we have, for example, let me copy this one first. Okay. If we have a knight here, let's consider, for example, here. Then do you agree? We can ignore this one, we can ignore this one, we can ignore this one, this one, this one, this one, this one, this one. Right?
And then just one out of the other 2.
And you agree these two have problem with each other, can select one of them at least. So it is that what?
Same.
No. Ah, sorry. Why? Thank you. So we're proving the same thing. We should prove this one or this one, right? Okay, so let's try. For this one, we can remove this one, 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 right? Here we can select at most, we can select 3 of them, right? So let's see, we can remove which cell. If we select, for example, this one. Do you agree we can remove this one, this one, this one, this one, this one, this also, and this one. So do you agree in this case it is at most 2?
Uh-huh.
Okay. Now we can remove this one, right?
Mm-hmm.
Okay. Now let's consider,
Oh, why are we removing it?
because I want to say,
Oh,
can we have 3 or not? If we select this, 3 is not possible, right? I want to find cases, because if all cases are at most 2, the problem will be solved. I want to find the cases that it will be 3, right?
Isn't it when it's the diagonal edges? Like the diagonal
I want to find all cases. I should find all of them. Okay. If I don't need to find one example, I should check and find all cases that it is 3 and see what happens. Okay. Because it is proof. So this one you can ignore, this one, this one, this one, this one. You can ignore this one, ignore this one, ignore this one, this one, this one. Now, do you agree these 2 have problems? So again, it is at most 2, right? Agreed?
Right.
Okay. So if we, let me paste it again. So we can remove this one, we can remove this one, and we can remove this one, right?
Mhm.
Okay, so here, if we select this one, okay, let's check this one. Do you agree then we can remove this one, this one, this one, this one, this one, this one, this one. Do you agree again it is almost 2? Agreed?
Yeah. Mhm.
So we can remove this, right?
Mhm.
Hmm. What about, let me check. This case, you can remove all these things. This one. Do you agree you can remove I am thinking of something. Do you agree when we remove this? We can remove also this one, right?
Mm-hmm.
We can remove also this one, right? And you can
Right.
remove also this one, right? Agreed? Agreed these cells should be
Agreed.
removed. When we remove this one is similar to this one. This one's this one, this one, this one, right? Okay. Now what cells are left? This one, this one, this one, this one, two. Okay, so can we say anything about this? So let's select this one. Do you agree we can remove this? We can remove this one. We can remove this one. We can remove this one. So again, do you agree in this case? Again, it will be at most 2.
Mm-hmm.
Okay, so we found one more. So we can remove, let me see, this one, right?
Mm-hmm.
And then we can remove this one, and we can remove this one. Agreed? So only these 5 cells are left, right?
Mm-hmm.
So now let's see which of them have problem with each other. Do you agree 1 and 1, these two can attack each other? So let's do something. Let's write 1, 2, 3, 4, 5, okay? So we can say what? We can say, let me minimize it. 1 and 2 have problem with each other, right?
Right.
1 and 3 don't have problem with each other, right? But 2, 3, 3, 4, 5 doesn't have problem with each of them, right? Agreed?
Okay.
So if you want to
Yeah.
select 3 of them, what are the cases?
3. It's 153 or 254.
Yes, we have only 2 cases for selecting 3. And that's good because we need to only check these 2 cases if it is 3, and then we can conclude something for these things, right?
Mm-hmm.
When we want to select 3, we cannot select 3 from this square, so we have to select 5, right?
Right.
And if we want to select 2 from this square, we should select opposite vertices. That's the reason we have only these 2 cases, right? So we can say what? We can say in each of them, if it is at most 2 always, the answer will be at most 16. Otherwise,
Oh,
there exists at least one 5 by 5 that has 3 knights. So this case or this case, we should check these 2 cases, okay? Want to try rest
oh.
on your own or one more hint?
Could you give more hints?
Okay, sure. So let's copy, let's paste it. So case 1, I'm selecting this one, and this one, okay? 1, 5, 3. Case 2, if I select in opposite direction, this one, this one, this one, okay? Do you agree we should check these 2 cases?
Right. Mm-hmm.
Okay. So and so let's remove all cells that we know have problem. Do you agree we can remove? We should remove all these cells here.
Right. Oh, for the first case, is it that with the corner you can cross out the middle of the fourth square? Like
With this
the
corner,
no, the other corner.
this
You can
one.
cross out the middle, yeah, of the bottom 5 by 5.
Yes, we can remove many cells. You can remove this one, you can remove this one, you can remove this one, this one, right? And also you can remove this one. You can remove this one. You can remove this one, right? And by this one, you can remove this, right?
Right.
Okay, and we cannot remove any other cell, right? And similarly, we can remove same cells here, right?
Right.
This one, look, this one, next diagonal, and then last one. So this one, this one, this one. Let's see this one, right? Can we do
The other.
this one, this one, right? Also, we can remove this one, right? Okay, so we should remove this one. So we can remove also this one, but we cannot remove this, right? So here also we can remove, for example, we can remove this one, right?
Right.
We can remove this one. We can remove this one. We can remove this one. Agreed? We can remove this one. We cannot remove any more cells, right?
Right.
Okay, now let's see what happens in this case. Do you agree here? How many cells, how many knights can we select at most?
2.
2. And if you want to select 2, the only possible case is we cannot select 3 because it should be this one. Because if you want to select 3, we have to select mid one, right?
Right.
Now, do you agree here? We have all these pairs have problem with each other. So do you agree here? You can select at most 1 and at most 1. Because look,
Okay.
no. Sorry. Here you can select 2. These 2. Oh, can we select? No. It's not possible, right? And
Right.
also this cell is this one. So you can select at most 1. So in this case, it was better because if it is 3, at most 1, so it will be at most what?
At most 8. So 16.
No, not 8. At most,
So 14.
yeah, 7. So in this case, it was less than the thing that we wanted, right? So it means that it's not good to have something like this. Then it causes bad cases in other 5 by 5s, right? Want to check this case on your own or want hint?
I can try to check on mine.
Okay, sure, try.
Oh, with the blue, if you can
Cross out everything but 3 points on the
So
two adjacent.
let's remove the cells that we cannot use. Do you agree here? We should remove all these white cells.
Yeah.
And then here we should remove this one. We can 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 remove this part.
And then
We can remove this one. This one. This one. Only these cells. You can also remove this one, right? Can we remove these cells? No.
I don't think.
Okay, so similarly, we can remove same things, right? So let's see. This one, these 2, then these 3. So these 3, right? Then from last one, this one. So it will be, let me check, 2, 3, 3 again. So next 3 is here, right? And last one is this one. Agreed?
Right.
Okay. So again here, do you agree it will be at most 1?
Yeah.
All of them have problem with each other. So 3. And this one again is at most. Here, you have problem in this spot, right?
Yeah.
So our only problem, if it is 3, do you agree here it's at most 3?
Yeah, but if it's 3, the 2 adjacent to it are 0.
Yes, but it's not important because
Oh.
3 at most 8, so at most 16, right? Understood completely how we solve this problem?
Yeah.
Try 4. Try 4 first on your own, okay?
Did you give hint for this?
Okay, sure. So for this one, you should prove some lemmas first. For example, one of the lemmas that you should prove is, let me copy. This one to 4. In first step, try to prove, for example, if we have something like this, and if we draw altitude through this, altitude through this, suppose it is A, it is B, it is C, it is D, it is E, it is F. Try to prove BFEC cyclic. Okay?
Yes.
Try.
Oh, I got the proof. It's just that AF
Over AD.
Mhm.
So AD over AD from similar triangles.
AF over
And then
what?
AF over AD equals AD over AB.
Let me write AF over
AD equals AD over AB.
ABS, then what?
And then AE over AD equals
Yes, exactly. You can say AD squared is AF times AB is equal to AE times AC, right? So we can say, because AF times AB is equal to AE times AC, we can say it is cyclic quadrilateral, right? Now in this problem, we want to prove two things. First, we want to prove that the 6 points are cyclic. Then after that, we want to prove the center lies on IG, right? Now use this lemma, this theorem that we prove, and see here we can say what quadrilaterals are cyclic, okay? Have you found any of them?
Oh wait. IAA is perpendicular, right?
Which is perpendicular? This one?
Mm-hmm.
Perpendicular to BC?
To IBIC or no?
Yes, because internal angle bisector, external angle bisector.
Okay.
Yes, yes. Okay, try to prove.
Oh, so doesn't that mean that
PB, UC, IC, IB is cyclic, and then
Exactly. We can find lots of cyclic quadrilaterals, right? But let me tell you something. Do you agree that we can consider our main triangle is this one, right?
Mhm.
Then do you agree this length will be altitude of the triangle, right?
Mhm.
So we can consider what, for example, we can consider our main triangle is that, and then let's draw altitude like this. Then we can say what? We draw perpendiculars from each of them to these lines, right? And for example, this one, right?
Mhm.
And what else? This one and this one. Okay?
Mhm.
So it is A, B, C. For example, we consider this one, this one, this one. We consider it is D, E, F. And we say what? We say, okay, for this one, for example, we call it PB, QB, right?
Mhm.
Then, for example, PA or QA, for example, PA, and then QC, PC. Do you agree we can consider this and we can prove, if we prove PA, PB, PI, PA, PB, PC, and QA, QB, QC are cyclic, it is exactly equivalent to previous problem. Agreed this?
Yeah.
Okay, so here by lemma we can say lots of them are cyclic, right?
Right.
For example, we can say BQC, PBC is cyclic, right? By the theorem. It is for length BC, for side BC. For side AB, it will be what? AQB, right?
PAB.
PAB is cyclic. And for AC, PC, QA, C is cyclic, right? Now use these cyclic quadrilaterals and try to prove extent C, for example. Can you prove 4 of them are cyclic or not? Okay. You can use some angle chasing because then, for example, you can connect. Let me connect with green. You can connect this one, right? And then you can say this angle is what? This angle is what?
That angle QCPB. Oh, that's B.
Yes, because it is cyclic. So we can write a lot of angles by using this, and then you can prove, for example, instead of 6 of them, try to prove, for example, 4 of them are cyclic. Then try to prove 5 of them and then 6 of them, okay? One more hint or that's enough?
That's enough.
Okay, sure, try. One hint or wanna keep trying?
And you give hint.
Okay, sure. So if we use angle chasing and I connect this one to, let me connect this one to this one. Can you tell me this angle is what?
That's
So let me ask you first this. This quadrilateral is cyclic. Why?
oh wait, E D E.
Yes, E
Oh, because 9.
no, 290 see the same side, right? This angle is what in triangle ABC?
Wait, DE is B.
This angle is
Oh wait, which?
this one. Can you see?
Oh, okay. Oh wait.
Do you agree in triangle ABC it is cyclic AEDB?
Oh, okay, yeah.
Because
Oh,
290 see the same side. So this angle is what then?
okay.
Yes, exactly. It is A. This angle will be what then?
That will be A.
Yes, so this angle is what?
Oh, C.
Yes, so we found all these angles for PB, right?
Right.
Now for others also we can say similar thing, right? You can connect this one and like this one to F and this one to next one to next side. So we can connect this to this one. So again, this angle is what?
That's oh, that's oh C.
Exactly, because this is cyclic, it is C, this one is C, right?
Great.
So good job. What about this angle?
Oh, that's A.
Why A?
B.
B, yes, because in first theorem it is cyclic, right? So it is B. So this one is A, right? Okay, so we proved for this one also. Now, if we connect again red one and next one on this part, right? So this angle is what?
That is B.
Yes, because it is A, it is C, it is B, right? This angle is what?
Oh, it's C.
Yes, for each of these 6 points, and this one will be what then?
A.
Yes, for each of these 6 points, we should write like this. So again, for F, we have FQB, for QC. We have this one, we have this one, and we should connect to what? Again, do you agree we can connect this one?
Oh,
Okay, so can you tell me this angle is what?
that angle. Oh, that's C.
Exactly. This angle is what?
Oh, A. Sorry.
Yes, let me tell you something. Because it is parallel to this one, right? This one is parallel to this one. So it is B, B, like this. So similarly, this one is parallel to this one, right?
Mhm.
So you can say it is A, and this one is B, right?
Right.
For PA, you can connect these two with this one. Is it correct to connect to this one? Let's see. It is B, it is A, it is C, right? For PA, we should connect it to QB, right?
Oh,
Then we can say this angle is what?
that angle. A.
Exactly. And the next angle is what?
Next angle.
This angle
Oh,
is B, right?
BC. Right. Yeah, that's
Okay, and last part, this angle is what?
B.
This angle is what?
A.
Exactly, and this angle?
C.
Yes, now we should remove lines that are not important, okay? So if we consider this, for example, you can say, okay, these lines, these points, so QC, it is A, it is B, it is C. So, or you can remove lines that are not important, and you can prove that by these angles, because we found all lots of angles. You can prove 6 points are cyclic, P's and Q's. Okay. One hint for this one, want to try on your own?
Could you give hint for like which lines to remove?
Okay, sure. So here, if we consider this part, let's only focus on the lines that we have. Okay, so here, for example, B, C, A. Let's remove this line, okay, because we don't need that. Let's remove this line. Let's remove this line. And what else can we say? Do you agree we can remove this part? And do you agree we can remove this part? It is not needed, right?
Mhm.
And let me check. Here we said it is B. I think here we had close mistake. If you connect to this one, it is B, not that one, right? This one is B, right? Because it is cyclic. And
Yeah.
this one
So,
is A, right?
right.
Okay, now here C, so A. Do you agree we can remove also this one? This one.
Mhm.
And these ones are not important. Okay. Now, do you agree it's easier to work with now?
Right.
Okay. Now here, by these angles, we want to use cyclic quadrilaterals. Can you tell me one quadrilateral that is cyclic? There are lots of quadrilaterals that are cyclic. Can you tell me one of them?
So PC, QB, PB, QC.
PC, what then?
QB,
QB,
PB, QC.
then what? PBQC you said?
PB.
Yes,
Yeah.
because it is C, right? So we found this cyclic quadrilateral PC, QB, PB, QC. And do you agree we can say also QB, PB? Let's see, can we prove this one? If we consider these four lines, it is C, this one is C. Do you agree these four lines are also, these 4 points are also cyclic?
Okay. QB,
So,
PB,
yes, because
QA,
PC, QB,
Okay.
yes, PB, QA is cyclic and they have 3 common points. It is important, right?
Right.
So, do you agree all these 5 points are cyclic?
Then QC, PA, QA,
Yes, we can use this one and prove another one. You said which of them cyclic?
Oh, QC, PA, QA, PB,
QCPA, then what?
QA, PB.
QAPB you said?
Yeah.
On this one. Because you say it is C, right? Okay, and PB. So again, we can say because QAPA, from these two, we can say, okay, all of them are cyclic. PC, or let's just start from this. QC, PC, QB, PB, and QA is cyclic, right? And QC, PA, QA, right? Let me check. QC, why we said here QC? QC was cyclic, so we wanted to prove what is cyclic. PA, QC, QC, QA, QA, PB, PB, right? So 3 common points, so PA cyclic. So we proved all 6 points are cyclic, right?
Right.
Now we should prove why the center lies on IG, right? Want to prove this now or next session? Both of them are okay with.
Oh, could we prove next session?
Okay, sure, we can prove it next session. Okay, any question?
No, I think.
Okay, so have a good day.
Okay, thank you. Bye.
Thanks. Bye. Hi. Hi. Hello. Hi. Hi. Can you hear me? Hi.
Hello.
Hello, how are you? I'm right, thanks. See my screen?
Yeah.
Okay, last session we were working on this problem, remember?
Mhm.
Okay, so step by step we proved that this hexagon is cyclic, right?
Right.
Then the problem says prove that center of this circle uh, is on line IG, right?
Mhm.
Okay, so let me tell you a hint for this one. For proving this, one bad thing is all of them, they are not, for example, good points, right? For example, to draw angles. I, G, and center of this circle. IG here, IG of this triangle. And because we've considered altitudes, it will be IG of orthic triangle, right? We should prove IG and circumcenter of this circle are concurrent, right?
Okay.
Can you tell me I of orthic triangle is what of ABC? I of DEF is what point for ABC?
Oh, so this is angle bisector in the
Yes, it is intersection of angle bisectors in center of DEF will be what of ABC? Let's.
Is it?
Is it what?
Oh wait, no, sorry, no.
Okay, so let me draw ABC and let me draw this one, and this one. This one is ABC. This one is D. This one is E. This one is F. If we connect DEF, I of DEF is what of ABC? Try to find this first on your own, okay?
Oh, okay.
Oh, sorry, it's H of ABC.
Exactly, because this altitude is angle bisector, right? Because it is A 90 minus A, 90 minus A, right?
Right.
Okay, so we should prove circumcenter of circumcenter of this hexagon, quadrilateral hexagon, and H of ABC and centroid of DEF, they are collinear, right?
No.
But before that, let me tell you a lemma. Suppose that we have 3 points, and these 3 points we draw 3 perpendiculars. For example, something like this. And we have these 3 points, and we have this part. It is suppose, for example, this point is x, this point is y, this point is z, a, b, c, d. Theorem x, y, z are collinear if and only if a over b is c over d. Okay? Try to
Okay.
prove this theorem.
Okay.
If you're proving from right to left, do you
Assume there's like y prime that it's collinear, such that it's collinear.
Have you proved from left to right?
Yes.
Yes, from right to left, you should use contradiction. For example, consider xy, for example, passes through another point. Then you should
Right.
use previous part and reach contradiction. Understood?
Right.
Okay.
Understood.
Okay, I think I got it.
Okay, can you explain?
For left to right, I said similar triangles. A over b equals xy over yz equals c over d.
So let me draw for left to right. We can connect them, for example, by green. And then you draw perpendiculars, right? And also here. Then Because you drew perpendiculars, then here it is C, it is D, right? A, B.
And
A over B is what over what?
A over B is xy over yz.
Which is equal to?
C over D.
Exactly. For right to left, this is structure so much useful. For right to left, you consider contradiction, right?
Mhm.
Okay, suppose, for example, x, y, z are not concurrent, are not collinear, right? For example, let me change z to another point. Okay, so it is our z and it is z prime. Then what?
Then xy. Oh, so A over if you draw a perpendicular from z prime to other side, it'll be like A over some e equals c over d. But then you'll get b equals e because A over b is c over d. And then so they must have so z and
Yes,
z prime must be the
contradiction.
same point.
Yes, exactly. So good job. Now we want to use this approach for proving that the 3 points are collinear, okay? So
Okay.
we have a circumcenter for this. Let's do something. Let's consider this part. Let's erase the things that we don't need. So here, let's erase all these things. And we can erase also this part. Okay, now you can use the theorem to prove that I of DEF, which is H of ABC, right? Centroid of DEF and circumcenter of PC, QB, PB, QA, PA, QC. We want to prove they are collinear, right? You can use previous lemma. Want hint or want to try first on your own?
I'll try first.
Okay, sure, try.
Oh, in the question, it's G.
G of DEF, not G of ABC.
Because we changed this. Look in the problem, it says in this figure G of ABC. Okay, means what? Because we've considered IA, IB, IC is ABC. So ABC is orthic triangle of that, right? Okay, then it will be G of G of orthic triangle. Okay.
Okay.
Okay. Want hint or want to keep trying?
I'll keep trying.
Okay, sure.
Could you give a hint?
Sure. So, um, here, do you agree if we consider perpendiculars to, for example, two sides, if the ratios are equal, by previous theorem, they are collinear, right? Agreed?
Great.
So, do you agree if we draw a perpendicular to one side and calculate the ratio, and the ratio is not related to that side? For example, the ratio is a plus b plus c over 2. So similarly, the ratio, for example, or 2, for example, times ABC, something like this. Do you agree then we can say anything that is not related to only this side? So we can say similarly, it is, for example, it is equal to 1 half. Then ratio here is equal similarly 1 half, so they are collinear, right?
Okay.
Okay, so let's erase all things. We want to calculate only perpendiculars to one side. So I will erase this one. Erase this one, this one, this one, this one, this one. We don't need them. This one. Q. This line is important. For QA. This line is not important. Let me erase, and erase all these things. Okay, so it is our Q of A, right? So if I draw from O, or let's call this O01. If I draw perpendicular to O1, from O1 to this, can you tell me here, for example, what this length is, what in terms of this length? What's the ratio of, for example, suppose it is T PAT to TQA. Want me to tell you the ratio is what?
Yeah.
Do you agree O1 is circumcenter of this? Also, it passes through these 2 points.
Okay.
So when you have a circle and you have a chord and you draw from O to this perpendicular, what's the ratio of these 2 lengths?
Equal.
Exactly. So do you agree they are equal?
Mm-hmm.
So we can say we found one of them. So let's consider it is 1050. It will be something like this from O1. Okay? So from O1 it is M. So we've considered perpendicular of 1 point, right? For another point, H is good again. Is D, right?
Mm-hmm.
So we found 2 of the points, 2 from 3 points that we want, right?
Right.
So we should focus on only G of DEF, right?
Mm-hmm.
Okay, let me copy this. Let's focus on what happens for G. Let me erase this part. Let me erase this part. If we draw, consider this. Let me draw with blue. Suppose this triangle, okay? And it is what? It is 156, 50, 28, 78. So it will be some point like this. If we draw median, right?
Mm-hmm.
For example, L. Centroid, do you agree, is 2/3, 1/3 of this?
Right.
Okay, so if we, for example, want to calculate, it is what? It is around 8127. So it will be a point like this, right?
Mm-hmm.
It is G of that point, it is this, okay? Now we can say what? We can say, we can draw this perpendicular. It is L prime, suppose it is G prime, okay? So do you agree L prime is midpoint of DQA, right? Because L is midpoint. And this one is parallel to this one, so DL prime is L prime QA, right? So let me tell you something. Do you agree we know exactly QA is what point? We can calculate the length because QA is from E, right? And we can find, for example, this length in terms of ABC because we know E, right? And we have this point. This is good. Also PA, right? Also D. D is a good point because it is feet of this, right? Foot of this
Right.
altitude. And then you say, okay, L prime is midpoint of QAD, right?
Mm-hmm.
Okay, so L prime is a good point, right?
Right.
Now, do you agree this is 1/3, 1/2 of this, right?
Mm-hmm.
So on this line, we can say what is half of what, or what is twice what?
PAG prime twice G prime L prime.
PAG prime is twice G prime L prime, right?
Mm-hmm.
So we found G prime because PA is good, this is good. So we found also G prime is what? So you should draw these perpendiculars and you should calculate dg over dg prime over G prime M, right?
Okay.
If for example this one is 3/4, then the problem will be solved, right?
No.
One more hint or that's enough?
That's not position.
Okay, sure.
Is it 2?
It's 2, yes, exactly. It's 2 and so because 2 is not related, right?
Right.
So we can say what? We can say they are collinear. Agreed?
Okay.
Okay, good job. Hi.
Hello.
Hello, how are you?
I'm okay. How are you?
I'm right, thanks. So let me share my screen. Uh, Let me open the file. Okay, so last session we tried problem 1 and 2, right? We solved them. And for problem 3, I told you these things, right?
Right.
Remember them? We proved that
Yeah.
by angle chasing, we proved that ABC, EXH, CHY, TXY are concurrent or similar by angle chasing. And we said something about these things. N, I told you ABC, TXY. And they are similar, agreed?
Right.
T was what? T was this, XY. So we want to prove LKH are collinear. So I said we should prove H and N are N should correspond to N. N should correspond to H, right?
Right.
Then we said, okay, we should prove NB over NC is equal to HB over HY, or NB over BC is equal to HX over XY, right?
Right.
Okay, want hint for this part or want to try on your own first?
I'll try more.
Okay.
N is the intersection of the altitudes in TBY.
No. N is in this triangle, in this figure.
Oh, okay.
I said ABC is similar to TXY, right? I said if LKH are collinear. Do you agree it is similar to EFN that are collinear because feet of altitude, L and K, right?
Yeah.
So we should prove N and H are corresponding points, right?
Right.
Okay. So try this part, let me know if you want a hint, okay?
Mm.
Could you give hint? Because I tried Menelaus for triangle ABC with EFN, but I'm not
Not sure how to relate it to TXY.
Okay, so at first, have you found, for example, NB over BC or
We
NB
found
over
CN over B.
You found what?
CN over NB.
It is what?
EC times FA over AE times BF.
No, in terms of only ABC. For example, angles of ABC, sine A, cos A. You should find this. Then, want me to tell you or want to find it on your own? Okay, sure.
Okay, I proved it.
How?
So CN over NC is B cosine C over C cosine B.
Yes, something like that. Hmm. Right. We can use Menelaus's theorem, right?
Right.
Okay, so let me copy this in a new file. Not too conscious. Not too. Uh, 3 is okay. So let me write NB over NC times EC over EA times FA over FB. We know is 1, right?
Right.
EC is what?
EC is A cosine C.
Exactly. A cosine C. EA.
EA is C cosine A.
Yes. FA.
Um, FA is A cosine B.
FA no.
Oh, sorry. FA is B cosine A.
Yes.
BF is A cosine A.
Exactly. And we can cancel A cos A, right?
Mm-hmm.
So NB over NC is equal to C cosine B over B cosine A, right? B cosine C. Okay, now we should prove why this one is also equal to what?
To HX over HY.
Yes. Now one thing for this part.
Oh, I got that part. It's because I said C cosine B over B cosine C is equal to DB over DC, where D is the foot of A, the perpendicular from A to BC.
Okay. Let me write C cosine B. C is this one. Cosine B. So this one. C cosine B you said is what?
DB over DC. DB.
D is what? This part?
Yeah.
Okay. So let me write this one.
Mhm.
dB over dc. Okay, then what?
Right. And then triangle CHY similar to triangle BXH. We've proved it, I think,
CHY
previously.
is similar to ABC, yes, all of them. Then what?
Then B
You said
corresponds to
which two
C,
triangles you consider? Which two triangles can you say it again? CHY and
BXH.
okay, then what?
C corresponds to B, HX corresponds to HY, so BD corresponds to CD,
So let's
and
consider.
therefore, mhm,
Let me CHY. This one we said this angle is what?
that's gonna be B.
B. This angle is C. This angle is what?
A.
Yes, and BXH, it is B. This angle is what?
C.
C. This angle is A. Then now we know what corresponds to what. You said what side corresponds to what?
Oh, I said so BD and CD correspond to each other.
BD.
So
Oh,
yeah.
this one. Yes. BD here, CD here, altitudes, right?
Right. So BD over CD
Yes.
equals HX over HY.
Exactly. HX over HY. So you proved, right?
Yeah.
Okay, good job. Now, let me tell you, I solved problem um, 8 completely, again by using only a small examples. So let me tell you how to solve this problem. You said you tried this problem, right? Before?
Yeah.
So let's try a bit together to see this what. So here, let's write phi of some numbers. Okay, small numbers. Phi of 1 is what?
1.
Phi of 2,
2.
1.
Yeah, 1. Okay.
Phi of 3,
Okay, yeah. 1. Or 2, sorry, 2.
2. Yes. Phi of 4 is what?
5, 4 is 2.
Yes. Phi of 5 is what?
4.
Yes. Phi of 6 is what?
2.
Exactly. And let me tell you something. You can say, for example, when M and N are relatively prime, if GCD of M and N is 1, or for example, if GCD of A and B is 1, we can say phi of AB is equal to phi of A, phi of B. We can easily prove this by the formula I told you, right? You can prime factorize because if you factorize them, then A and B are different, they're primes, right? And you can write it like this. Phi of 7 is what?
5, 7 is 6.
Yeah, so phi of 6 is phi of 2 times phi of 3, right? 2 times 1, 1. Phi of 8 is what?
4.
Phi of 9 is what?
6.
Yes, 9 over times 2 over 3, 6. Phi of 10 is what?
5, that's 4.
Yes, this times this 4. Phi of 11 is what?
10.
Phi of 12?
5, 12 is 4.
Yes, this times this 4. Phi of 13?
12.
Phi of 14?
6.
Phi of 15?
8.
8. Okay, that's enough. Now, let's consider something. I want to first work on prime numbers, okay? Like exactly the Sumac problem, or let me tell you, many problems that we should prime factorize, right? We solved problem also in AMC 2023 that we consider one prime, then power of that prime, then two primes, right? We want to do exactly the same thing. If n is prime, is it correct or not? Let's check. Phi of p, we want to see. Does it divide p or not? Phi of p is what?
P minus 1.
Yes. It's prime.
And
Phi of p is p minus. So, divide. You wanted to say what?
Oh, sorry, no. Yeah.
Okay,
It
so
won't divide.
it won't divide py.
Oh, because phi of p, unless there's really oh, sorry, phi of p minus 1 would have to be 1 or p. Phi of p minus 1 is less than p, so phi of p minus 1 would have to be 1. Sorry.
Exactly. So why it is not 1?
The only way phi of p minus 1. Oh, it only works for p is 3. That's I think the special case.
So let's check. Let's check as a lemma. If phi of n is 1, then n is what? Okay.
Okay.
So we can want to prove this part on your own to find all n or one hint.
I can try to prove it.
Okay, sure. Try.
Oh wait, I'm not really sure if this is the right proof, but
Is it you assume for p1 raised to alpha 1, p2 raised to alpha 2 until pq raised to alpha q? The
Then phi of n is what? The formula of phi of n.
p1 raised to alpha 1 minus 1, p2 raised to alpha 2 minus 1 until pk raised to alpha k minus 1 times p1 minus 1, p2 minus 1 until pk minus 1, sorry.
Yes, it is 1. So what can we conclude?
So
At first we should
alpha
consider
1,
we have prime factorization, or n is what?
n is prime?
No. For prime also we have prime factorization. So what number doesn't have?
N4.
Yes. And 1 is one answer, right?
Right.
So here, what can we say?
So since they're all like each of them are positive integers, and each has to be one. So I said alpha 1 to alpha k equals 1. So the first expression has to entirely be
So we can consider how many
0,
primes are
or
there?
just one prime.
Yes.
But
K is 1,
so it's
and alpha 1 is what? 1. So,
1.
and also, so n is 2 only, right? 1 prime, the power of prime is 1, and it is 1, p1 is 2, right? So only n1 and 2 are answers, right? Okay, so from here we can conclude, because it is 1, so p minus 1 should be what or what?
Should be 1 or 2.
Yes, 1 or 2. So what can we conclude? P is what or what?
P is 2 or 3.
Finished, okay? So we found 2 good answers, except here and 1 and this is not our answer. So P2 and 3 satisfies, right? And N1, what about N1? Pi of 1 divides 1 or not?
It does.
Yeah, so before considering primes, we should check 1. So N1 is another answer, right?
Right.
Okay, so we considered 1 prime, only 2 or 3 possible. Now in next step, we should consider n equals what?
PQ.
Let's consider first 1 prime. We can consider P what?
P raised to alpha.
Exactly. If we saw that P raised to alpha is hard, we check P squared P cubed then P to the alpha, right?
Okay.
Okay, so let's try this one together.
It's going to be
Yeah, so what I'm saying? Pi
P of alpha. P raised to alpha minus 1 times P minus 1
divides what?
divides P raised to alpha.
If you want to check this one on your own or one team?
I can check, but do you take cases for this or?
Let me. No, I use the previous lemma that I reached.
Okay.
Okay. Maybe I consider 2 cases, but it is not case.
Okay.
Okay. One to try on your own.
Sure, I'll try.
Okay.
It's only true if P is 2.
P is 2. 2 to the alphas are good.
Yeah.
Why other numbers are not good, and why is 2 to the alpha good?
Because so that since GCD of P and P minus 1 are is 1, so then you can separate the P of P raised to alpha 1 out P raised to alpha minus 1 and P minus 1, so it's Phi of P raised to alpha minus 1 times Phi of P minus 1 divides P raised to alpha, and then the Phi of P raised to alpha minus 1 is P raised to alpha minus 2 times P minus 1. So P minus 1 has to divide P raised to alpha, which only occurs when P minus 1.
Yeah. Here, do you agree? We can, because we know these 2 numbers are relatively prime, we can write it like this, right?
Mm-hmm.
Do you agree this?
Yeah.
You said from here you wrote like this, or you considered phi of this number completely?
Separated.
Okay. So we know this number is what?
That's Phi raised to alpha minus 2 times P minus 1.
It depends. Agreed, because maybe alpha is 1, right?
But then, can't you say without loss of generality, alpha is greater than or equal to 2? Because if alpha is 1, that's just the previous case.
Exactly. So we can consider here alpha is at least 2. So we can say it is P alpha minus 2, P minus 1, right?
Right.
So from here, because we know P minus 1 and these are relatively prime, P minus 1 divides what?
P minus 1 divide P raised to alpha. That only happens when P minus 1 is 1.
Yes. Also, you can say, do you agree when A divides BC and GCD of A and B is 1? What divides what by Euclid's lemma?
If GCD, oh, A divides C.
A divides C, exactly.
Okay.
So P minus 1 and P raised to alpha are relatively prime, so P minus 1 divides what?
P minus 1 divides 1. Oh,
Yes, P minus 1 divides 1. So P minus 1 is what?
P is 1. So P is 2.
Yes, and we can see that if it is 2, it is 1, 1, it divides, right? So n2 to the alpha works, right? Alpha at least 2, right? But because here we had 2, we can say 2 to the power of any number, right? At the end, we will combine all our solutions, okay? And here, let me not. Well, let's do something. For other numbers, we can say, okay, n is 2. So 2 to the alpha, these, 1, these, we have 3 parts for our answers, right? Now. Okay, now next step, we should consider what?
Next step, let's consider N is PQ.
Yes, PQ. Or we can do something. We can say, for example, P to the alpha 1, Q to the P to the alpha, Q to the beta, right? And if we couldn't solve, we try to use a small example, right? Okay, so we know phi of n should divide n. Want hint or want to try on your own?
We can try.
Okay, sure. Want hint or want to keep trying?
Could you give hint?
Okay, sure. So let's try it together. Without loss of generality, suppose P is less than Q, okay?
Okay.
Now we can say phi of n is what in terms of PQ alpha beta?
P raised to alpha minus 1 times P minus 1. Q raised to beta minus 1 times Q minus 1.
Yes, exactly. Or like this, right? Divides what?
Divide P raised to alpha Q raised to beta. Or N.
Exactly. So now we know Q is greater, right? And Q minus 1, E minus, we can say, do you agree we can write it as a phi of Q because we know Q is relatively prime to all these numbers, right? Because all of them are less than.
Oh,
What?
my question was. Oh, sorry.
Okay, agreed this?
Oh, okay.
Then do you, because we know this one is relatively prime to this, because Q and P are relatively prime, all these numbers are relatively less than Q, so because Q is prime, they are relatively prime with Q. Then we can write this one as what? Again, we have two cases, right? Case
Right.
1, beta is 1. Case 2, beta is greater than equal to 2. So in this case, we can say what? This one will be what?
Oh, it's going to be Q raised to beta minus 2 times Q minus 1. So Q minus 1 has to divide Q raised to alpha.
Yes. So q minus 1 divides p to the alpha, right? So q minus 1 is p to the I, right? So
Yeah.
what can we say? Q is p to the I plus 1, right? So here we can conclude something. We can conclude what?
We can conclude, so q minus 1, oh, so it's, oh, so oh. You can simplify the other phi, or phi of p raised to alpha minus 1 times p minus 1 times q minus 1.
Pay attention to parity and this equation.
Oh, even odd, so p is 2,
Yes,
q
p
is
has to be
3.
2, right? No, q not 3 necessarily, because maybe 4 plus 1, 5, right? Or for example, 16 plus 1, 17,
Yeah.
lots of cases. So p is 2. Now that p is 2, we can replace, right? We can say, okay, it is pi of 2 to the alpha minus 1 q to the, or we can write it like this. We can say q beta minus 2, right, times q minus 1 times phi of 2 to the alpha minus 1 times q minus 1, right? Divides 2 to the alpha q to the beta, right?
Right.
Okay. Now here, q is p to the I plus 1, so q is 2 to the I plus 1, right? I can conclude again another result if I replace. Want to try on your own or one thing?
I'll try.
Okay, sure.
Oh wait, I think I got it.
So it only works when q is 3.
Q
And then,
is 3. Why?
so I substituted the q is 2 raised to I plus 1 into the q minus 1. So it's the phi of 2 raised to alpha plus I minus 1, which becomes q raised to b minus 2, q minus 1 times 2 raised to alpha plus 1 plus I minus 2.
Yes, here times r, for example, divides 2 to the alpha q squared, right? We can ignore q, right? We simplify q. Only we should focus on 2 to the alpha, right?
Right.
So 2 to the
Oh, and where does r?
q minus 1. No. Sorry. We don't have any r, right? So we know this part is 2 to the alpha minus 1 minus 2 plus I, right? So we know alpha minus 2 plus 2i is less than or equal alpha, right? So I is at most 1, right? So I should be positive, so I is 1. So q is 3, right?
Right.
So we proved that n 2 to the alpha times 3 to the beta, when beta is at least 2, it works, right?
Right.
And we can check it to make sure. Phi of this is 2 to the alpha minus 1, 3 to the beta minus 1 times 2, right? Well, phi of this is 2 to the alpha, 3 to the beta minus 2. If we consider it again, 2 to the alpha minus 1, again 2 to the alpha, 3. Why I said 3 to the beta minus 2? 3 to the beta minus 1, right?
Oh, okay.
So 3 to the beta minus 2, right? Divides this, and we will see it's okay, right?
Right.
Okay, you don't need to write this. Maybe you can also write it in answer sheet, but if you don't write, I don't think they won't subtract mark because we've considered completely. Now we should consider if beta is 1, right?
Right.
Okay, let's consider this case, if beta is 1. Want to check this case on your own or want hint?
I can try and check.
Okay, sure.
Could you give hint? I couldn't get it.
Okay, sure. Let me tell you something. So here, beta is 1. So the form of our number is what?
The form our number is P raised to alpha Q.
Exactly. So here it will be 1, right?
Right.
So we know p to the alpha 1, p minus 1 times q minus 1 divides p to the alpha q to the beta and or q, right?
Mhm. Right.
Okay, so then we can say what? Do you agree it is even? It is even these. If p and q are odd, if p and q be odd numbers, do you agree it's multiple of 4 and then it doesn't divide this because phi of 4 or any multiple of 2 is even?
You'll have
Green.
yeah. Mhm. Right.
Okay, so
Mhm.
here we can say what? If. So we can say if. We know p and q, if p and q are greater than or equal to 3, then 2 divides odd, and that's a contradiction. So we can conclude p because we said p is less than q, p is 2, right? So phi of 2 to the alpha minus 1 times q minus 1 divides what?
To the alpha Q.
Yes, and because we know that the q is not important, because here it's 2 times something, and then phi of that again won't be q, right?
Right.
Okay, so we can say q minus 1, suppose, is 2 to the, for example, I or j times s, that s is odd, right?
Right.
So it will be what? It will be 2 to the alpha minus 1 plus
Plus J minus 1.
1 times phi of s, right? Divides 2 to the alpha. So what can we conclude?
J minus 2 is less than or equal 0, or J less than or equal to 2.
That's minus 2 less than or equal alpha, so j at most 2, right?
Right.
So it can be 4 times odd number or 2 times odd number, right?
Right.
Okay, so, but we know that phi of s, so let's consider something. If j is 2, then phi of s divides what?
Then phi of, if J is 2, then phi of S divides 4S plus 1.
No, pay attention to this.
If J is 2. Oh, phi S divides 1.
Yes, so then by that lemma we can say s is, phi of s is 1, so s is what?
S is 1 or 2.
Yes, but because s is odd, s is 1 only, right?
Right. Okay.
So q will be what then?
2 raised to J plus 1, or 2 raised to 4, 5.
5. So n is 2 to the alpha times 5, right?
Mm-hmm.
Agreed?
Agree.
Okay. Now, j is, in next step we can say if j is 1, then phi of s divides what?
Phi of S divides 2.
So phi of s is what or what?
Phi of S is 1 or 2.
If phi of s is 1, then s is what?
Is 1, or yeah, S is 1.
And q is what?
Q is 3.
So n is what?
3 raised to alpha times 3.
Yes, another. Now, next one. Let's consider something. We consider as, for example, lemma 1, that if phi of n is 1, what happens? Now we should consider as lemma 2, phi of n equals what?
2.
2. Then n is what? One hint for this part or want to find it on your own?
I can try and find it.
Okay, sure, try.
Is it n is 4, 3, and 6?
You said, is it what or what?
4, 3, 6.
4, 3, 6, why?
Oh, I just took cases. No, because I said n is p1 raised to alpha 1, p2 raised to alpha 2 until pk raised to alpha k. And then I proved contradiction if k is greater than or equal to 3, so k less than or equal to 2. And so if k is 1, I got that p1 is 2 or p1 is 3, so it's 4 or 6, 4 or 3 there. Or if k is 2, then I got it becomes 6.
Okay, so let me write it. We should use again formula, right?
Right.
So n is p1 alpha 1 to pk alpha k, right?
Mm-hmm.
So n is p1 alpha 1 to pk alpha k. So phi of n is p1 alpha 1 minus 1, right?
Right.
Pk alpha k minus 1. We have many terms. One of them should be 1, other terms should be one term should be 2, and other terms should be 1, right?
Right.
Okay. So we have two cases. If p1 minus 1 is 2, then all other terms should be 1, right?
Right. Mm-hmm.
So we can say what? All other terms because should be 1. We can have at most one more elements because p2 minus 1 should be 1. The others should be different, right?
Right.
So here p1 is 3, right? And the power should be 1. And for this one, p2 should be 2. So from here, n can be 3, right? Or 6.
Mhm.
Agreed? If
Right.
one of these terms equal to 2, for example, p1 alpha 1 minus 1 is 2. So we can say n is 2 squared, right? 4. You said n is 3, 4,
Mhm.
6?
Yeah.
Okay, good job. Now we prove n is 3, 4, 6. Now that we prove this, phi of s is 2, we can conclude s is what here?
S is 3, 4, or it's 3 or 3.
3. So q is what?
Q is 6.
Is 2 to the js, 2 times s, 6, plus 1, right?
Oh, okay.
So q is what?
7.
So n is what?
N is 2 raised to alpha times 7.
Exactly. Okay. So we've considered all cases with 2 primes, right?
Right.
For 3 primes, I remember I rejected greater than equal 3 primes. Want to reject 3 primes and more primes now or next session? Both of them are okay with.
Could we do next session?
Okay, sure. Any question?
No.
Okay, so have a good day.
Okay, thank you. Bye. Have a good day.
Thanks. Bye.
I think I proved it partially, but there's one case that I can't prove.
What is the case?
When the power of p sub k is, or alpha sub k is 1.
What do you mean?
Huh? Oh, wait, because if n is p1 alpha 1 until pk alpha k, the case when alpha k equals 1.
Okay, so let's see. Suppose and we can say P1 less than P2 to PK, right?
Alright.
And we can say phi of n. Phi of n is what?
P1 raised to alpha 1 minus 1, P2 raised to alpha 2 minus 1 until pk raised to alpha k minus 1 times P1 minus 1, P2 minus 1 until pk minus 1.
Exactly.
And then
Divides P1 alpha 1,
P1
P2 alpha 2 to PK alpha k. Then what?
And then I said that you could like separate pk raised to alpha k minus 1 since GCD of any other term with pk is 1.
Yes. And
And so it becomes pk raised to alpha k minus 2 times pk minus 1. And so you can say pk minus 1 has to divide p1 raised to alpha 1, p2 raised to alpha 2 until pk minus 1 raised to alpha k minus 1. And then you'll get p1 is 2.
Or we can also say, it is even, right?
Oh, okay.
Because it is even, so P1 should be 2, right?
Oh, okay.
Then what?
P1 is 2. Oh, wait. And then what was it? Oh, and then I said pk minus 1 would have to be 2 raised to b1, 2 raised to b2 until pk minus 1 raised to bk. Oh, wait, yeah. I
No, we cannot say. You said they are power of 2?
No, I said that pk minus 1 would be 2 raised to b to 1, p2 raised to b to 2 until pk minus 1 raised to b.
Yes. We can say P, for example, I minus 1 is 2 raised to bi. 2 raised to, you said what?
b1, b to 1
Times what?
times p2 raised to b to 2,
Hmm.
p3.
Times ri, which is odd, right?
Oh, okay.
Okay.
Mhm.
Then what?
And then, so within that, you can say that um the power of 2 so it'll be phi of 2 raised to alpha 1 minus 1 times 2 raised to b1 plus b2 until bk.
Yes, we can say what? 2 to the power of what divides this?
2 to the power of alpha 1 minus 1 plus k.
K minus 1. Right?
Oh, okay.
So 2 to the alpha 1 plus K minus 2. Right? Because K is at least 3, so 2 to the alpha 1 plus what?
Plus 1
Yes, K is at least 3.
divides 2 to the alpha.
So we can conclude what divides phi of this?
2 divides 2 to the
Alpha 1.
alpha. Okay.
If K is 4, we can reject this, right?
Right.
In case 3, we cannot reject this. Exactly. You can use this, but so we prove for K at least 4, we solve the problem. It's impossible, right?
Right.
So if k is at least 4, if k is at least 4, then alpha 1 plus 2. So then 2 to the alpha 1 plus 1 divides this, which this one divides 2 to the alpha 1, this, right?
Right.
And that's a contradiction, right?
Oh, okay.
What about for 3?
For case 3, I think it's similar. You can wait, oh, it's the same. P1 will be 2, and then you can let PI be 2 raised to BI RI, and then
Yeah, so we can, if k is 3, we can conclude, if k is 3, we can conclude pi minus 1 is 2ri. Power of all of them is 1, right?
oh wait, why?
Because look, if all of them is equal to 1, all of them is equal to 1, do you agree? This power of 2 divides them.
Yeah.
Let's consider k3. K3, it will be what? Phi of 2 to the alpha 1 minus 1, p2 alpha 2 minus 1, p3 alpha 3 minus 1, p2 minus 1, p3 minus 1, right?
Mm-hmm.
Divides 2 to the alpha 1, p2 alpha 2, p3 alpha 3. Agreed?
Mm-hmm.
So, do you agree? Because here alpha 1, then inside that can be power of 2 to the alpha 1 plus 1 at most, right?
Right. Yeah.
So here, because
Yeah.
both of them are
No.
even, they should be only power of 2, not 4, right?
Okay.
So each of them will be this, okay?
Okay.
Then what? Have you solved from here or not?
I solved it, but I got contradiction using power of 2, so I'm just not sure why it's.
I think for this part you not pay that attention. Only this special case is left, right? So one
But you just take case for previous. Oh, sorry. Never mind. Sorry.
okay, one hint for this one or one keep trying.
I'll keep trying.
Okay, sure.
Can you say contradiction? Because you can separate the phi of p3 raised to alpha 3
Minus 1. And if you do that, you get P3 minus 1, which has to be even. So it's 2 times 2 raised to alpha 1. So 2 raised to alpha plus 1. Alpha 1
Can you
plus
say
1
it again?
by 3. Oh, because we have 2 raised to alpha 1 plus 1. And then you can separate the phi of P3 raised to alpha 3 minus 1.
Okay,
And
if you separate that, then what
let's
happens?
Mhm. And if A3 is greater than or equal to 2, then
Maybe it is 1.
there's going to be a P.
Maybe it is 1. A3.
Oh, yeah.
What about that case?
Oh, I haven't covered that case yet.
Uh-huh. Yes, if alpha.
Sure.
One hint or wanna keep trying?
Could you give hint?
Okay, sure. So look, you can consider. We said this one is 2R2, right? This one is 2R3, right?
Sure.
So do you agree we can say it is equal to phi of 2 to the alpha 1 plus 1 times phi of p2 alpha 2 minus 1 p3 alpha 3 minus 1 r2 r3 divides 2 to the alpha 1. And this agreed?
Mm-hmm.
We can cancel these two things, right?
Mm-hmm.
So this part should be what?
P2 raised to some beta 2.
Yes,
P3
phi of
raised to
that
some
should be
beta 2.
odd. Because here we don't have
Mm-hmm.
any 2,
Oh.
right?
Mm-hmm.
So inside that is odd, right?
Oh, and so
So
if
phi of odd number is odd. under what case it happens? Suppose, for example,
1.
why?
Hmm?
Why it should be 1?
Oh, because otherwise, if there's a prime in there, then the phi of it will include the prime minus 1, which will be even, considering
Exactly.
the prime is.
Yes, so this one should be 1. It means R2, R3 should be 1, but that's a contradiction because then P2 is equal to P3 is equal to what?
Equals 3.
3, but we know they should be different, right?
Right.
Okay, so we solved this problem completely, right?
Mhm.
Okay, now let's solve another one. Let me tell you. Copy the figure. I didn't have time to work on all problems, but I tried also 8 last problem. Have you tried any of them from 1 to 8?
Okay, I tried 4 and 8. I think. Yeah.
4 and 8. Could you solve them?
I got partially through 4 for 8. I don't know if my answers were complete, but I remember I had a few answers. I forgot what they were though.
For 4, what have you done?
For 4, because from examples and pattern, I saw it was something like the answer was like something like 4, but then when I tried to generalize the proof, it was I don't know if my answer was correct, but it was related to like V2 or the power rate, like the largest power of 2 in n or something like that.
Yes, you can. I checked some parts of that, and I think I should check more. I think for these numbers are the numbers that it will be changed. 2 to the 2 to the m.
Oh,
Okay, for example, if we check for 1, and let me tell you also something about 4, some hints. The answer is 2 to the power of something
yeah,
for all n. And why? It says we should reach only 1, right?
right,
I said first, this f is 1 to 1.
right,
You
yeah.
should prove this. Have you proved this or not?
I remember I proved it in the. Oh, yeah, I
For
think.
example, look, 1, 2, 3, 4, 5 as an example. If 1, for example, is check, check, for example, cross, cross, check, can you tell me what goes to this one?
Oh, how many it can turn into? Oh, so 1 and then 2,
Yes, check.
check, check.
No, no. If it is check, then
Oh,
for 2 we
it's
will have
2. So
cross. So cross,
check, X, check.
and for 3 check, for 4.
Check.
Yes, because you say 1 and 2. These we have 1, and because it is cross, it should be even, so check, right? What about 5?
X.
Exactly. You can say when we reach a number, we should check divisors like 4 and also this part. If here we have even and cross, it should be cross. If, for example, we have odd number and this, you should write 4 cases. Okay? Understood why it is 1 to 1?
Yeah.
Okay. Now, so do you agree if we go to 1 to 1, I say, for example, F, 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 if we take this,
Right.
uh, it, we can't have this, something like
Yeah.
this. Why?
Oh, we can. Oh, because it says finitely many.
No, because it is 1 to 1. If you have this figure from two things, we reach same case, right? So the repetition we can say is simple like this. Okay? It is
Okay.
like a cycle. So suppose, for example, it is 1. If we start from, so if you want to find elements that go to 1, you can start from 1 and see, okay, it goes to which elements and then come back to 1, and we don't have any other cases. Understood?
Understood.
Okay, so we can say what? We can say, for example, for 1, let me write it. For 1, if you write 1, let me maximize it. Okay. If you write 1, for example, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can say something at first. For example, 1, 2, 3. Okay.
Right.
So it is 1. Then next one is what? Check X.
1, 2, 3. Oh, check.
Yes. And then
And then
check
check X.
X.
So it just repeats. So it never goes to 1.
Yes. So the length of.
Oh, it does.
So yes, for 3, the answer will be what then?
The answer will be. Is that 2? Yeah.
Yes, exactly. 2. For 2 is 2 also. For 3 is 2, right?
Right.
Now for 4, it will be what? Here, cross. Next one will be what? Cross or check?
Check.
This one, we can say only one check. What about next one?
Still check.
Yeah, so we should continue, right? Keep writing.
Mm-hmm.
Will we check. Next one is what? X. Next one is what? Check cross.
Check X.
If you pay attention, prime numbers are check cross, right? Always. Okay?
Check.
Yes. Okay. So for prime numbers, because when we have these, we know 1 is always check, right?
Yeah.
If it is check in the first step. So for prime numbers, it will be like this, right?
Right.
So this one and this one, because it is 1, 2, it is cross. So the length of 4 is what?
2, 3, 4.
Yeah, so as you can see in 4, we have change, right?
Right. Mm-hmm.
Then for 5, if we check for 5, it is prime. Do you agree it is similar to 2?
Yeah.
So because it is similar to 2, we know in 4th step it will be cross, like 2, right?
Mm-hmm.
Sorry. This one, this. For 6, what about 6? It will be cross, then what?
Check. And then
Yes,
cross.
check, cross, right?
No.
It's still 4. For 7, it is exactly similar to 2, right? What about 8?
Cross. Check. Cross. Cross.
Yes, here 1, 4. Cross, what else?
Cross.
Yes, 1, 2, and only 1, 2. So again, for 8 also the length is 4, right?
Mm-hmm.
Diagram 9 is similar to what? Can you tell me?
2, 4.
Yes, so you can write exact like, okay.
Mm-hmm.
For 10, it will be what? It is similar to what?
And is similar to 6.
Yes, like 6. For 11, it is similar to what?
11 is similar to 2.
Yes. So it will be like this. For 12, let's write. First one is cross, next one is check, right?
Yeah.
Then 12 has how many divisors?
6.
6, so all of them
So
check,
cross.
so next one cross. Now,
Mm-hmm.
1, 4, So it will be what in next step?
Oh, no.
What about next one?
6 cross.
Exactly. So for 12 is still cross. For 13 again is similar to 2, right? 14 is similar to what? 6, right? 15 again similar to 6, right? But for 16 again it will be changed. So first one is cross, next one is what?
Check. And then
Next one is what? Next one is what?
check.
Exactly. Next one is what?
Still check.
1, 2, 4, it's
16.
not 2. No, 3, yes. So for 16 we should continue, right?
Right.
Okay, so if you continue, you can do what? We should write next one, all of them will be checked, right? Do you agree? Do you agree? Let me tell you something. For this one, because we reached these, again we have these these parts, right?
Oh, yeah.
So we should have this, and then this one will be what?
X.
1. This one, x. Next one will be what?
X.
1, 2, 4. Yes. Next one will be what?
X.
Yeah.
Oh, wait, yeah. Oh, wait, yeah.
So x, right?
Mm-hmm. Right.
Okay. Because if you pay attention like this, it will be switched, right? Because all things here are same. When it is check and cross, next one will be different, right? Because it is the only one, right?
Mm-hmm.
Okay. Now we can say what? Like this one, if you see, for example, in 4, we have this, next one in 16, we have this, right?
Right.
In 16, the
8.
length is 8. So our claim is what? Claim is length of, we should say two things. Length of 2 to the 2 to the m is what?
Is m 2 to the m plus 1.
For example, 16 is 2 to the 2 squared, 2 to the m plus 1, right?
Mm-hmm.
And if you want to prove this, we should prove this one, and also we should prove if a is less than or equal to 2 to the 2 to the m minus 1, less than 2 to the 2 to the m, length of a divides 2 to the m, right?
Mm-hmm.
Okay, we should prove these two things. Claim 1, claim 2. For proving this part, again, we can reach some good results. We can say what? We can say, okay. Want to try to prove claim 1 first on your own?
Sure.
Okay, sure, try.
Could you give hint? I'm not sure what to prove.
Okay, sure. So here, when we want to work on 2 to the, for example, let's work on 2 to the power of something, okay?
Okay.
We want to see. Can you tell me what numbers are important to consider?
All previous powers of 2.
Yes, so we can say 2 squared, 2 cubed, right?
Mhm.
So, for example, 2 to the k minus 1, 2 to the k, okay? First, we know it's 1, 0, 0, 0. Let's consider cross as zeros, okay?
Right.
Then, for example, this one is 1, right?
Mhm.
This one is sum of them. Do you agree it's important it's even or odd?
It has to be.
For example, look, 1, 1, 1 plus 0 is 1, so all of them will be checked, right? Then, for example, 1 is 1, 1 plus 1 is 2, 2 is 0. 1 plus 1 plus 1 is 1, right? Like this.
Oh.
And then if you consider this one, for example, as A1, A0, A1, A2 to AK. AK minus 1, AK. Then next one is what? This one is A0, A0 plus A1, A0 plus A1 plus A2 to here. It will be A0 to AK, right?
Oh.
We can consider mod 2, right?
Mhm.
Then next one will be what? Will be A0, 2A0 plus A1. 3A0 plus 2A1 plus A2, right?
Mhm.
Last one is what?
It'll be KA0 plus K minus 1A1 until AK.
Yes, KA0, K plus 1 A0, right?
Oh, okay,
Because look, 3A0, 2AK, right?
yeah.
Now next line it will be what? This one.
A0. Oh, that one. Oh. Oh, isn't it so much like n times n plus 1 over 2 as coefficients?
We can consider what?
The coefficients will be like n times in the form of n times n plus 1 over 2.
Yes, next one. What about next line?
Um,
So if you want to write it, let me tell you a hint. Like k times k plus 1 over 2, then in next line, in for example, after 4 lines, it is hard to say it is what, right? But we can use hockey stick identity. It is k plus 1, choose k plus 1, we can say choose, for example, 1, right?
okay.
Then if you consider 1 choose 1 to this, it's k plus 2 choose 2, right?
Okay. Okay.
A0 plus k plus 1 choose 2, A1, right? So if you write, it will be k plus 1 choose 1, A0 plus k choose 1, A1 plus k minus 1 choose 1, A2, right?
Okay.
To last one is what? Is 1 choose 1, AK, right?
Mm-hmm.
And k plus 1, k plus 1, k plus 1. Next line will be what? Will be k plus 2 choose 2, A0, right? Plus k plus 1 choose 2, A1 plus k choose 2, A2 to 2 choose 2, AK, right?
Okay.
Next line will be what?
K plus 3 choose 0. K plus 2 choose 3.
Yes. So
1 until K plus 1 choose 3, A2 until 3 choose 3.
exactly.
8.
This one k plus 3 choose or 3 choose 3, AK, right?
Mm-hmm.
We should say this. Okay. Now we can say what? If we prove, we want to say L of 2 to the k. Do you agree if all of them? If we consider from here, okay. Suppose we consider from here. A0 is 1, A1 is 1 to AK is 1. Okay.
Okay.
So we start from this line, then next line. So it will be second one, right? It will be third one. So if we consider like this one will be what? A0 plus A1, A0 plus A1 plus A2. So it will be what row? This one, second row, third row, fourth row, right? Let me check it again. So A1 to AK, this one is second row, third row, fourth row, right? That's okay.
Yeah, okay, so, okay.
For example,
fourth.
previous one was what? K choose 0, we can write A0 plus K minus 1 choose 0, A1, right?
Mm-hmm. Oh,
So 0 choose 0, AK, right?
mm-hmm.
This one is third row. We want to see that for which row all these numbers will be even. Okay?
Mm-hmm.
And we want to prove L of 2 to the m is 2 to the m plus 1. So because we want to prove this, so we should prove what we know. Suppose we use induction. We know L of, we want to prove this, we know L of 2 to the m minus 1 is what? Is
2 to the m, yeah, 2 to the
m.
m.
Now when I want to prove this, at first, I should prove for 2 to the m, it is 1, right? And then when I prove for 2 to the m, it is 1, then I prove for next part, it is 0, okay?
Okay.
So here I should say what? I know this is second row, third row, so as you can see, for example, let's consider for 4, what happens? It is, we consider this one as, which one? This one as second row, right?
Alright.
So for 4, second row, third row, fourth row, right? For 4, fourth row, L of 4 is 4. Why you said L of 4 is 4? On second, third, fourth. In fifth row, it is 0 again, all of them, right?
Mhm.
So we consider first row, this one. First, second, third, fourth, fifth. Okay, so we should prove what? For example, like 4. In previous part, the length was 2, right? And as you can see here, we've reached this. But for 4, we've not reached that. So we should say it is, in this case, this one is 1, right? And then we should say what? We should say after fourth row, 1, 2, 3, 4, this one will be 0, right?
Right.
It means what? It means we should prove that, for example, if it comes the first row, second row, for which number we should consider 2 to the m, right? In first row, we know it's 0, right?
Mm-hmm.
In second row, we know all of them are 1, right?
Right.
So we know for all previous elements, we want to consider, for example, for previous one, in 2 to the mth row, the length is this, right?
Mm-hmm.
So in 2 to the m plus 1, m plus 1, we should prove why it is 1. We know all other terms will be 0 by induction, right?
Uh-huh.
So one thing we should prove is this. Another thing we should prove that in 2 to the m plus 1 plus 1, why it is 0. Agreed?
Okay. Perfect.
Okay, so we should prove these two things, and you can use these coefficients to prove that. Want more hint, or that's enough?
That's
Okay. Want hint?
yeah, can you continue?
Okay, sure. So here let's consider, say we said second row is what, right? Third row, fourth row. Now 2 to the m, this row is what?
It will be k plus 2 to the m minus 2. Choose 2 to the m minus 2 times a sub 0 plus k times 2 to times k plus 2 to the m minus 2
K, look,
minus
K is related to what? K here was for 2 to the K, right? Here, because it's 2, it will be 2m, right? 2 to the m. So it will be 2 to the m plus what? Choose what times a0?
2 to the m times plus isn't it plus k minus 2?
K is 2 to the m, right?
K to the m.
Agreed. Look, here it was, we were considering for 2 to the k here, right?
Oh, okay.
Here is 2 to the 2 to the m, right? So
Right.
it is 2 to the m plus what? Choose what for 2 to the m plus first row?
Oh. Huh? Oh wait. So
Pay attention here. It was, for example, fourth row, fifth row. What's the coefficient of a0?
to the m minus 2, choose 2 to the m minus 2.
Let's see. Look, for fourth row, it will be 1. For fifth row, it will be
Yeah.
2. So for this row, it will be this minus 3, right? Because 5, 2, 4, 1, right? So it will be 2 to the m minus 2, right? Choose what? Choose 2 to the m minus 2. Agreed this or not? If it is a bit hard, let's do something. Here, do you agree k is 2 to the m? Can you hear me? Can you hear me? Can you hear me? Hello, hello. Can you hear me? If you are saying something, you are muted. Can you hear me? Can you hear me? Do you have my audio? Hello, hello. Can you hear me? Can you hear me?
Hello.
Hello, hello. Okay, okay.
Yes.
So let me share the screen again. See my screen?
Yes.
Okay, so here I said, look, for fifth row, I said, okay, let's, for example, consider case 2 to the m here. Agreed? So it will be, do you agree in each step it is k plus rho minus 3, 5 minus 3, 2, 4 minus 3, 1. So it will be k, or we can say 2 to the m, plus this row minus 3, 2 to the m minus 2. Choose 2 to the m minus 2. Agreed this?
Okay.
Okay, and then for next one we can write same thing. 2, it will be what? It will be 2 to the m plus 2 to the m minus 2. Choose 2 to the m minus 2, a0, right? Plus 2 to the m plus 2 to the m. Here we should subtract, right? Okay, plus 2 to the m minus 3. Choose 2 to the m minus 2, a1, right? Then this one is a2 to the m, last one, right?
Mhm.
It will be 2 to the m minus 2. And this summation will be 2 to the m plus 1 minus 2. So it's this minus 2, right?
Right.
We should prove, and we know a0, a1, a2 to the m, all of them are 1, right?
Right.
So if we ignore these things, we should prove this one is even or odd.
Odd.
Exactly. And what's the other thing that we should prove for this one? It will be what? 2 to the m plus what?
Oh. Ooh, do you mean like
This row.
isn't it 2 to the plus 2 to the m plus 1 minus 2? Choose 2 to the m plus 1 minus 2.
Plus 1 minus 3 minus 2, right?
Right.
To 2 to the m plus 1 minus 2, right?
Right.
Plus 2 to the m plus 2 to the m plus 1 minus 3. Right.
Sure. Oh, sure.
2 to the m plus 1 minus 2. To last one is 2 to the m plus 1 minus 2, right? 2 to the m plus 1 minus 2. We should prove it is what? Mod what?
0, mod 2.
Yes. Now let's check to make sure for some small example to not have careless mistake. Suppose, for example, m is 2. This part will be what?
MS2, it would be 6 choose 2 plus 5 choose 2 plus 3, 4 choose 2 plus 3 choose 2 plus 3 choose 2.
So,
And then you transform 2 choose 2 into 3 choose 3.
yes, you can say 7 choose 3. All of them, high-castic identity. We should prove it is odd. 7 times 6 times 5 is odd, right?
Right.
And next line will be what?
For you, oh no, 10 choose 6 plus 9
6
choose
choose
6
6,
plus 8
right?
choose 6 plus 10.
Which is 11 choose 7. It should be even, right?
Right.
Which is obviously even, right? Because 10 is even.
Right.
Okay, so now for proving these two things, we can use like these small cases, high-castic identity, right?
Right.
So we can say what for first one? 2 to the m plus 2 to the m minus 1. Choose 2 to the m minus 1, right? Which is 2 to the m plus 1 minus 1, 2 to the m minus 1. We should prove why it is odd, right?
Right.
And for next part, we should say what?
2 to the m
Plus 2 to the m plus 1 minus 1. 2 to the m plus 1 minus 1, right?
Right.
So we can say 3 times 2 to the m minus 1, 2 to the m plus 1 minus 1, right? We should prove why it is 0 mod 2. So, and if you check, 2 squared is 4, 3 times 4, 12 minus 1, 11. 11, choose 8 minus 1, 7. It's okay. This one, 8 minus 1, 7. 7, choose 3. So we should prove it is odd, it is even, right? Okay, now for this part, let's prove this part that is even. V2 of. Hello, hello, can you hear me? Can you hear me? Can you hear me now? Hello, hello, can you hear me? Have my audio? Okay, let me change my net.
Hello.
Hello, hello, can you hear me? Can you hear me now? Can you hear me? Hello, can you hear me? Can you hear me? If you are saying something, you are muted. Can you hear me? Can you hear me? Hello, do you have my audio? Can you hear me? Can you hear me? Can you hear me? Can you hear me?
Hello.
Hello, hello, can you hear me?
Yeah. Yeah.
Let me change Google Meet. Let me send you another meeting ID. Maybe I think it's the problem from this meeting ID. I've sent you through the chat of this Google Meet. Have you seen the link? Okay, okay. And if you've not heard my audio, you can send message through chat that you can hear me or not. Okay, chat here. Okay, so click on the link, new link. See, can you join? Okay, can you hear me here?
Yeah.
Okay, I think that one had problem. Okay, see my screen?
Yeah.
Okay, so here, for example, let's prove this one that is even. We want to prove V2 of this is at least 1, right?
Right.
So do you agree V2 of this part, V2 of 3 times 2 to the m minus 1 times 2 to the m plus 1 minus 1 is what? Is sigma 3 times 2 to the m minus 1 over 2 to the, for example, a minus 2 to the m plus 1 minus 1 2 to the a minus what over 2 to the a?
Oh wait. So it.
Legendry's formula for this one. You know it is what?
Oh, the difference. The 2 to the m.
Yes, 2 to the
Yeah.
m.
Isn't it 2? Yeah. Isn't it?
Yes, so do you agree it is a1 to a to infinity? Do you agree it is at least 0 for each a, it is at least 0?
Yeah.
Because we know that x plus y is greater than, less than or equal to x plus y, right?
Uh.
Agree this x plus, sorry, x plus y greater than equal this, right? Because maybe the fractional part be greater than 1, right? So because of this, each part is at least 0. So if you prove only one of them is positive, then it will be solved. For at least one a it is positive, then we can say it is even, right?
Right.
Okay, so can you tell me for which a it is at least 1? Let's check, for example, a equals m, okay?
Mm-hmm.
Or a equals m plus 1. If a
Right.
equals m plus 1, this one will be what?
1.
Will be 1, because it is greater than 2 to the m plus 1, but less than. So it's 1, but you agree these two things will be 0. So it's 1. So we prove this part, right? Now, this part is a bit harder, because for this one, we should prove all of them should be 0, right?
Right. Oh.
So v2 of 2 to the m plus 1 minus 1 2 to the m minus 1 is what? Is sigma a is 1 infinity 2 to the m plus 1 minus 1 over 2 to the a minus what?
Minus 2 to the m minus 1 over 2 to the a minus 2 to the m over 2 to the a.
Exactly. Now here we want to prove for all a it is 0, right?
Right. Oh.
Do you agree this part is integer, right? For a m plus 1, do you agree it will be 0? Because all of them are less than. So we can conclude a is less than or equal m, right?
Right.
So we can say
Use.
this part is 2 to the m minus a, right?
Yeah.
So do you agree we can write it as like this? 2 to the m plus 2 to the m minus 1 over 2 to the a, this part.
Right.
Do you agree is 2 to the m minus a, because it is integer, you can take it outside.
Yeah.
So this one is equal to this one is equal to this one, so we prove this, right? Okay, so we prove this claim. I think it will be around 70% of the problem, or maybe more or a bit less. So we proved claim 1. We should prove this part, right? We proved that in these numbers we have a jump, right? For example, we proved that for 4 it is 4, for 16 it is 8. For next number that is important is what after 16?
Yeah. Uh, 2 raised to 8, which
Exactly.
is 256.
256. We know that after 8 steps it's not 0. After 16 steps it is 0, right?
Mm-hmm.
So we should prove numbers between them, okay?
Okay.
So this part I should try this. I didn't have time to try this. You can also try this one as homework, okay?
Okay.
That's homework 1. Now let me tell you something. For this one I proved for this one. I proved completely yesterday. So when L of 2 to the 2 to the m, we proved is m plus 1, right?
Right.
It was claim 1. Okay, and we use hockey stick identity for solving this, right?
Mm-hmm.
Now, if you prove this part, do you agree the problem will be solved?
Mm-hmm.
So, try to prove this claim 2 first on your own. Okay, one hint or one to prove on your own?
Can you give a hint?
Okay, exactly like these. That remember how we solved 2 to the k?
Mm-hmm.
For example, for a, if it is power of a prime, it is like 2 to the something, right?
Right.
And you can prove this. So maybe it is power of some primes, right? No,
Okay.
product of some primes, some power of primes. So, for example, we used stochastic identity, and we found that in each step, for example, 2 to the k is related to what? Then you can use, for example, 2 primes. For example, 2 to the k times, or p1 to the alpha 1, p2 to the alpha 2, or 2 to the alpha 1 times 3 to the alpha 2. You can find something similar. You should apply hockey stick identity and another thing. So you can consider first if you have two primes. P1 to the alpha 1, P2 to the alpha 2. If you find for two primes, then you can find for example, k primes. Okay? One more hint, or that's enough?
That's enough.
Okay.
Wait, can you give a hint? I'm not sure how to do this.
So I said consider two primes, right?
Mm-hmm.
So P1 alpha 1, P2 alpha 2, or 2 to the alpha 3 to the beta, right? Do you agree
Oh,
we
wait,
should
sorry.
consider, do you agree we should consider 2 to the alpha 3 to the beta?
P to the alpha 3.
We have two primes, right?
Right.
So we have lots of generality. Do you agree we can consider our primes are 2 and 3?
2, 3 primes?
No. Do you agree we've worked on one prime?
Mm-hmm. Right.
Do you agree when you know 2 to the k is what? So you know p to the k is what?
Yeah.
Okay. Now we can consider two primes without loss of generality. Suppose n is 2 to the alpha times 3 to the beta, right?
Mm-hmm.
Okay. Now if you see it's hard, you can start when I wanted to solve. I checked 6, I checked 12, then I found it is what? Want
Uh,
hint or want to check it on your own?
I can try and check on my own.
Okay, sure.
Wait, can you give a hint? I'm still not sure.
Well, let's consider 6 and 12 and let's generalize it, okay?
6? 6 for Q, it's the same as times, right? It just,
Yes.
like,
Exa-
0, 1, 0, 1, even odd.
exactly.
Just even odd.
Yes. So if we consider these for prime numbers, we said it is what?
Prime numbers, wait, sorry. If
For 2
we
to
say
the, for example, for 2 to the k, it will be what?
2 to the k, it will be
In mth row. What?
work here because we try this for 2 to the k.
No, we use 2 to the k, then 2 to the 2 to the m, k2 to the m. For this is for fifth row, right? And the agree we can say a1 to ak are 1, right? So, do you agree this one is what? What choose what?
This that's k plus 4 choose 4.
Yes. It is for which row?
6th row. So kth row will be 2k minus 2 choose k minus 2.
Let's write also this one. For this one, it is k plus 3, choose 3, right?
Right.
So, for 2 to the k, we can say mth row, or for example, tth row is what?
Kth row is k plus t minus 2 choose t minus 2.
K plus t minus 2, choose t minus 2, right?
Mm-hmm.
Also, we can write that k plus t minus 2, choose k, right?
Oh, okay.
Agreed?
Mhm.
Okay. Now we want to consider 6, 12, and then 2 to the alpha, 3 to the beta. Let's see what happens. When we have 2 to the power of something, we should only consider 1, 2, 2 to the 1, 2 to the 2 to the k minus 1, and 2 to the k, right? But for 6 we should consider which numbers?
1, 2, 3, 6.
Yes. So again, we can say it is 1, 0, 0, 0, right?
Yeah.
Then it is what?
1,
Yes.
1, 4, 1, 3, 3, 9.
Yes, so let's write it 1, 2, 2, 4, right? So as you can see, do you agree here we can say 2 choose 1, 2 choose 1. And here we can say 1, 2 choose 2. Here 1 choose 1, 1 choose 1, 1 choose 1. Agreed?
Six.
Yes, next one is what? 3 choose 2. 3 choose 3. 3 choose 2. 3 choose 2. Agreed? If we use this formula.
Right.
So it is what? It is second, third, fourth row, right?
Yeah.
So fourth row
Oh,
is
sorry.
4 minus 2. K is 1. 4 minus 2. 2k is 1. 3. 3 choose, you can say for example 2, right? Agreed? Okay, and 6 is what? If you pay attention, for example, for this one, it is 4. Can you guess that how we can calculate for like these cases?
It's 1 n squared or t squared.
It's t squared. What if we consider, for example, for 4? Do you agree we can say it is 2 choose 2 or 1 choose 1? Yes, 1 choose 1. But let's write for next one. It is 9, right?
Right.
Do you agree
You choose
this
1.
one is, yes, 2 choose 2 plus 2 choose 1 times 2 choose 2 plus 2 choose 1, right? Like it is similar, the formula is similar to sum of positive divisors. This one is related to 1, this one is related to 2 to the 1, this one 1, 3 to the 1. Agreed this?
Mm-hmm.
So, why we have this? Because do you agree for 9, we should consider sum of 2, this one, and this one, and this one, right?
Mm-hmm.
So, when we consider 2 choose 2, 2 choose 2, it is like what? This one it is 3, this one it is 2, this one it is 6, right?
Right.
So, it will be like that. Now, for other parts, we can say same thing. So, we can write it as what? This one to choose to choose. Let me check to choose two. Oh, sorry. Here it was 2, right? But we should write. Let me see. Here let's write this one as. Let's write this one 1 1 1. Let's write this one as 1 choose 1. Okay,
Right.
and let's write this one as 2 choose 2. Okay. So
Mm-hmm.
we can write it as 1 choose 1, 1 choose 1 to be able to apply stochastic identity. So it will be 3 choose 2, 3 choose 2, right?
Um.
So now we can say this one is what? 3 choose 2 squared, right?
Oh wait, how did we get 1 choose 1?
2 choose 1 squared. Like, how do you
Get
How do we get what? These numbers?
The one. Oh no, sorry. The 1 choose 1 plus 2 choose 1 times 1 plus 1
I
plus 2 choose 1.
said when we want to consider 6, do you agree we should consider 1, 2, 3, and 6?
Yeah.
So do you agree when we write like this, it is similar to 1, this one similar to 2, this one similar to 3, this one similar to 6? You can create all of them. Some of them 1 choose 1 times 1 choose 1, create this one. This one creates this one. This one creates this one, 3, and this times this create this one, 4. Right?
Alright.
It will be these things, right?
It creates 1, 2, 2, and 4. Okay.
Yes, previous one, 4 is what?
4 is. Oh, the 2 choose 1 squared?
Yes, to choose ones. And then you can prove this one like induction, okay? And after 6 proving this, you can work 12 and you can generalize it for 2 to the alpha, 3 to the beta, similar formula, okay?
So it's the same. Is it so it's similar for 12?
Yeah, similar for 12. And then for 2 to the alpha, 3 to the beta, and also you can generalize it when we have P1 alpha 1, P2 alpha 2 to Pk alpha k, okay? So try to generalize it and you should use induction, okay? Like this P1 alpha 1, P2 to Pk alpha k. Try to see the formula for this in, for example, T row will be what, okay?
Okay.
Try this one, I go and come back in 2 minutes, okay?
Okay.
Isn't like n choose alpha, n minus 1 choose beta, or something like that?
For 2 primes or k primes?
2 prime.
2 primes. Okay, so let's see. So at first, for 6, for Tth row, or let's write, for example, for rth row. For 6, it will be what?
6, it'll be. No, wait. R minus 1 choose R minus 2 squared.
2 squared, right?
Mm-hmm.
Okay, and now let's consider 2 to the alpha, 3 to the beta, okay?
Mm-hmm.
So we know what numbers are important. 1, 2, 2 squared. 2 times 3, right? 2 alpha minus 1, 3 beta, 2 alpha, 3 beta minus 1, right? All these numbers are important, right? So, if we consider like that, before that, let's calculate 12, okay? Let's calculate,
12 I got.
uh-huh,
For 12 I got. Or for here, if we're doing rth row, it'll be r choose 2 times r minus 1 choose 1.
okay, so let's try 2, 3, 4, 6, 12. For rth row, it is what you said?
R choose 2 r times r minus 1 choose 1.
R choose 2 times R minus 1 choose 1, you said?
Yeah.
Okay, let's check. 1, 0, 0, 0, 0, 0. 1, 1, 1, 1, 1, right?
Alright.
And then we know this one is 1. For powers up to, it will be what? For 2, it will be, we can say this one is 1 choose 1, right? For this one, 2 choose 1. For 4, 3 choose 1, right? For this, 2 choose 1. For 6, we can say it is what? 2 choose 1 squared,
Yes. What? Okay.
right?
Alright.
And for 12, it will be what?
It'll be 2 choose 1 times 3 choose 1.
Mm, 2 choose 1, 3 choose 1, right? Okay. So now let's check this one. For next row, let me cut this word. For next row, we know this one is 2 choose 2, right?
Mm-hmm.
Then 3 choose 2, 3 choose 2, then what? 4 choose 2, right?
Right.
Then for 6 it will be what? 3 choose 2 squared, right?
Yeah.
Okay, for 12, if we want to consider, we can say again, 1 choose 1, right? Plus 2
Right. Plus
choose
2 choose
1, plus
3 choose 1.
3 choose 1, so it is for 1, 2, 4, right?
Right.
Then 1 choose 1 again for 1, and for 3 2 choose 1, right?
Right.
So it will be what? It will be 4 choose 2 times 3 choose 2, right?
Mm-hmm.
So let's write it like the 3 choose 1, 2 choose 1. Next one, 4 choose 2, 3 choose 2, right?
Right.
Similarly, we can say, and why we can say it will be good? Because look, 1 1 it's this, 2 1 3 will be this. For example, 2
Right.
times 3 is 1 choose 2, 1 choose 2. It's 1 choose 2 squared, right? That's the reason I said by induction you can prove, right? So
Right.
for third row it is this, for fourth row it is this. So you can say for rth row r choose 2, and this one 3 choose 2, r minus 1 choose 1, exact. So let's see it is what. So
Mm.
now suppose that we want to consider for 2 to the alpha 3 to the beta, okay?
Yeah.
So it was what? 4 choose 2, 3 choose 2 was for fourth row, right?
Right.
For fourth row, here it will be what?
And 4
1 choose 1, right? 2 choose 1, 2, what choose 1?
Uh, fourth row will be oh until until um
It was for 12. 12 was 2 squared times 3.
wait,
For fourth row, we had these things. Now it is 2 to the alpha.
how will it be alpha plus 1?
Yeah, exactly. Times. Again, 1 choose 1, 2 choose 1, 2 what?
Beta plus 1 plus 1?
Exactly. So it will be what then?
It will be alpha plus 2 choose 2 times beta plus 2 choose 2.
Right. It is for fourth row, right? Can you guess for fifth row it will be what?
Alpha plus 2 choose. Oh, wait, no. Oh, fifth row. Oh, no. Fifth row will be alpha plus 2 choose 3 times beta
So
plus 2 choose
let's
3.
let's check. For fifth
Oh,
row, let's write it like this. It will be what choose what if you want to write.
1. Oh, fifth row 1 choose 1.
One choose one, so let's do something. Let's again generalize it for 12. For 12. So we wrote all these things, right? This was fourth row, right? Now let's consider
Mm-hmm.
fifth row, okay? So can you tell me it is what choose what? First one, second one.
3 choose 3.
Yes.
4 choose 3. 4 choose 3. The next one's 5 choose 3. And then 4 choose 3 squared. And then it becomes 5 choose 3 times 4 choose 3.
Yes. So now that we found this, Can you say for fifth row it will be what?
Alpha plus 3 choose 3 times beta plus 3 choose 3.
Yes, alpha plus 3 choose 3. These two will be 3, okay? And beta plus 3 choose 3, right?
Right.
So for rth row it will be what then?
Alpha plus r minus 2 choose r minus 2 or choose alpha times beta plus r minus 2 choose r minus 2 or choose beta.
Okay, and by induction we can easily prove this. Okay, like exactly the thing we did for 12, right?
Okay.
Okay, the answer you reached for P2 alpha 3 beta was this or different?
I think it was a bit different, but
Okay, understood completely how we reached this.
yeah.
Okay, now next step is what? You should calculate for n p1 alpha 1 to pk alpha k, okay? Want hint this for this one or want to try on your own?
I can try.
Okay, sure, try.
Is it for the rth row for p1 raised to alpha 1 until pk raised to alpha k?
It'll be alpha 1 plus r minus 2 choose alpha 1, alpha 2 plus r minus 2 choose alpha 2, and then that until alpha k plus r minus 2 choose alpha.
Exactly. And we can prove it by induction, right? Again, you should consider brackets like this for each primes. And write if n is p1 alpha 1 to pk alpha k, alpha 1 plus r minus 2 for rth row, choose alpha 1, alpha 2 plus r minus 2 alpha 2, to alpha k plus r minus 2. Uh, it will be for 1, it's r minus 2. For 1 prime, also it was r minus 2. Yes, for 1 prime, also it was r minus 2. Alpha k. Okay, do you know how to prove this by induction?
You do induction on k?
Mm, you can use induction on k, but because we want to, I can say on alpha 1 plus, on k and also alpha 1 plus alpha 2 to alpha k. Because do you agree, for example, we should use this minus 1 for reaching this?
Right.
You should also use alpha 1 plus alpha 2 to alpha k. All numbers that are divisors of this. Okay? You should consider that you prove this for example, uh, yes, alpha 1 plus alpha 2 to alpha k. Okay? And then when it
Right.
is 1, you should consider, you can also write this alpha 1 plus alpha 2 to alpha k plus k. Okay? Then when you consider a divisor, at least one of them will be decreased, right?
Alright, sorry, could you explain that again?
Mm, look, for example, when you consider only alpha 1 to alpha k, for k, for proving this, do you agree we should use, let's do something, let's try to prove this, okay? Could you prove this or not?
Which part?
That our
Oh,
throw is this.
not proved, no.
Okay, so let's see if we want to use induction. Uh, we know it is equal to what choose what plus to what choose what.
Choose 1 plus 2, choose 1.
No,
Sorry. True, it will be alpha 1 choose alpha. Oh, wait, no. R minus 3 choose R minus 3 plus r minus 2, choose r minus 3 until alpha 1 plus r minus 3, choose r minus 3.
Yeah, r minus. So if you consider, for example, like this one, we had 1 alpha 2 choose 2. So it was choose 1 r minus 3. Yes. R minus 3 choose r minus 3, right? Plus r minus 2 choose r minus 3. Plus to what choose r minus 3? So let's write it as like this. R minus 2 we can write.
Okay.
What choose r minus 3?
Alpha 1 plus r minus 3.
Yes, we want to see it means what, right?
Right.
Then it is P1 alpha K to PK alpha K. Do you agree when we want to calculate these, for example, we should calculate consider all divisors of this?
Uh-huh.
For example, P1 alpha 1, P2 alpha 2, 2pk alpha k minus 1, to pk alpha k, right?
Right. Uh-huh.
So when you want to see it is r in rth row, it is what you should consider? In r minus first row is what, right?
Right.
So, we know what we want to use this, okay? We can use induction or on r. We can use induction on r, okay? We know, let's see, it is what? In first row, it is 1, 0, 0, 0, 0, right?
Mm-hmm.
In second row, do we agree it will be 1, 1, 1, 1, 1?
Uh-huh.
Now, base case is R2. Do you agree base case is correct for all of them?
Base case is correct for all.
Because when you replace
Yeah.
R2, all of them will be 1. And it is correct.
Right.
All of them equal to 1, right?
Yes.
Okay, now let's consider this form is correct for example, r minus 1, and we want to prove for r, right? So, do you agree that if we want to, so let's consider, I want to say these numbers are, for example, a r minus 1, 1, right? To a r minus 1, p1 alpha 1 to pk alpha k, right? Do you agree? Understood it means what? For example, this one, AR, P1 alpha 1 to PK alpha k. We want to prove why this one is equal to AR, P1 alpha 1 to PK alpha k. Agreed?
Oh wait, the AR P1 alpha 1 PK alpha K, is that just notation?
Yes, yes, yes.
Okay.
AR, for example, and M means in R row, M is what, right? Okay. Now, we know that AR and P1 alpha 1 to PK alpha k is equal
Sum
to,
of
yes, sum of
oh,
d divides n. You know n is this, right?
right. Uh-huh. ARG.
A
AR minus 1D.
exactly. Okay, and we want to use this, okay?
Okay.
So, do you agree that these things are we can consider it depends on the primes and are separated? Agreed? Like phi of n. This
Right.
the one is related to P1 alpha 1, this one P2 alpha 2, right?
Uh-huh.
Okay, so do you agree because D divides N, we can say P1 beta 1 to PK beta k, which beta I is less than or equal alpha I. We can write divisors like this, right?
Alright.
And AR minus 1D. So by induction, it will be what choose what to what choose what.
It will be each one less than alpha 1. It will be by induction, sorry. It will be sorry. For induction here, does that mean you can apply the formula?
It is AR, we consider for R minus 1, it is correct. So we want to apply this formula for R minus 1, okay? And for this divisor, okay? This. So it will be what?
It's still some form of AR minus 1D, no? Or
Yes, AR minus 1D, but this one is ARN, right?
yeah.
We know the formula is correct for R minus 1, right? By induction. So if we apply for R minus 1, it will be what?
Oh, AR minus 1 will be D is summation of AR minus 2D.
No, AR minus 1 and D. D is here, I replace D with, because we know D divides N, right? So do you agree D
Right.
P1 beta 1, P2 beta 2 to PK beta K?
Oh, okay.
So it will be what then? By applying, now I want to use this by induction for R minus 1, right?
Okay. So it'll be beta 1 plus R minus 3. Choose R minus 3. Beta 1 plus beta 2 plus R minus 3. Choose R minus 3.
Exactly.
Until beta 2 plus R minus 3. Choose.
Exactly. Beta K plus R minus 3. Choose R minus 3, right?
Right.
And it is correct for all P1 beta 1 to PK beta K. Beta I is less than or equal alpha I, right?
Right.
Now, do you agree? Because beta I can be from 0 to alpha, right?
Yes.
So I can write this one as, I say, okay, let's focus on only beta 1, P1 beta 1. Beta 1 can be from 0 to alpha 1, right? So it will be R minus 1, choose R minus 3. R minus 3, choose R minus 3. If beta 1 is R minus 2, choose R minus 3, right?
Right.
Plus to alpha 1. It will be alpha 1 plus R minus 3, choose R minus 3, right?
Oh.
Plus times, you can do the same thing to last one. Again, R minus, again, exactly like sum of positive divisors. Look, when you want to find sum of positive divisors of, for example, 12, sum of positive divisors of 12, yes, it is what? It is, for example, 2 to the 0 times 3 to the 0 plus 2 to the 1 times 3 to the 1, right? Or 3 to the 0 plus last one 2 squared times 3 to the 1. So do you agree you can say it's equal to 2 to the 0, 2 to the 1, 2 squared times 3 to the 0, 3 to the 1?
Okay.
And here, because we are considering on all things like this, so here, because we have two brackets, because here we have k parts, we have k brackets, when we have k primes, right?
Okay.
R minus 2, R minus 3 to alpha k plus R minus 3, choose R minus 3, right? And then it will be what? First bracket is what?
It is R minus A1 plus R minus 2 choose R minus 2.
To last one is what?
Last one is AK plus R minus 2 choose R minus 4.
So we proved, right? It is exactly the thing that we wanted to prove. this one, right? Okay, so we use induction on R, and R2 is our base case, okay? Okay, now that we proved this, so we prove AR, this one in Rth row is this one, right?
Right.
So now one part is left. What part? We
Show it divides.
exactly. We should prove this one, that claim 2. We proved that we proved claim 1, right? That length of 2 to the m is 2 to the. Now I want to prove when a is between these and strictly less than these, why this one divides this, okay?
Oh.
Okay, want hint for proving claim 2 or want to do it on your own?
I can try.
Okay, sure, try.
Huwag siya sama sa kanya.
Right.
Kaya dalawa, yung master ko mo kasi dalawa na. Pwede ba?
Could you
Take a pin.
Okay, sure. Do you agree that we proved claim 1, right? By claim 1, we can say L of 2 to the, let me write with other color. We can say L of 2 to the m minus 1 is what?
Is 2 to the m.
Yes. It means what? It means, let's write 1, 2, 3 to 2 to the 2 to the m minus 1, then some numbers a to 2 to the 2 to the m minus 1, right? So if you write these numbers, at first it is 1, 0 becomes the first row as this, right?
Right.
Next row is what?
All one.
Exact. And we want to, we know in which row it is second row. We know in which row, again, we have 1, 0, 0 until this part.
2 to the mth row.
2 to the mth row, right?
Was that by induction?
Here we prove.
I don't know, but like
By
showing
claim
like,
1. And not all of them 0, until this point.
oh, okay.
Okay, now a is a general number between from here to here, right? And let me check. In 2 to the mth row it is this. No, it is not in 2 to the mth row. It is what? In which row we have this?
Plus.
Exactly, right?
Wait, is the first part gonna be a bit induction because you're saying that like all the numbers
Which
between
part? First part means this one.
oh no, like the one like 100 for the 1 until 2 raised to 2 raised to m minus 1.
I don't know which part exactly.
The 1, 2, 3 to the 2 raised to
This
2
one.
raised to m minus 1. No, the one before it.
This one.
No,
Or this
the
one.
one.
Which
The one below.
and the one below.
The one.
This one. Or this one or this
Yeah.
one. So let me write 1, 2, 3. Which of them?
It's the one below 3, like the 1 0.
And this one is dot dot dot. We will reach.
Sure that.
You say why all these things are 0, right? We can use induction. Suppose, for example, for previous cases it is okay. Now we want to prove in this interval, okay? Okay. Now, suppose we consider this part is 0. Now we want to prove that this one is also 0, okay? So, here we can say what? We want to prove why this one is 0, right? Okay, so A is what? Form of A, we can prime factorize A, right?
Right.
P1 alpha 1, P2 to alpha 2 to, for example, PR alpha R, right?
Right. And it's alpha 1.
Because we had this, let's write PK alpha K, okay?
Right.
But in general, it's better not use, because we used 2 to the K in previous case. It's better to not use same variables, okay? Suppose, and also we can use Q beta 1, something like this, or X1. But suppose A is P1 alpha 1 to PS alpha S. I want to prove what? I want to prove it will be 0. I know the formula of this. We found this, right? Remember? In this part, we found this formula. Now, if we want to calculate this for 2 to the m plus first row, it will be what?
Alpha 1 plus 2 raised to m minus 1, choose 2 raised to m minus 1. Alpha 1 plus 2 raised to m, choose alpha 2 plus 2 raised to m minus 1, choose 2 raised to m minus 1 until alpha s plus 2 raised to m minus 1, choose 2 raised to m minus 1.
We should prove it is what?
Prove it is 0. Or 0 mod 2.
Yes, we should prove it is even. Okay. And we know that this number is less than 2 to the 2 to the m, right? Because this number is less than 2 to the 2 to the m. And if you consider this, we can, if we don't use this part, do you agree we don't need to use induction? Agreed? We want to say
No.
if A is less than this, in this row it is 0. If we don't want to use this part, so we don't need to write induction. Agreed? So here also we can say it is not necessary. By claim 1, we know it is 0. But A is a number, any number here, we want to prove it is 0. Okay?
Okay.
And this one is 0 because of claim 1, right?
Right.
Okay, so now we have only this condition. A is this, is less than 2 to the 2 to the m, and we want to prove why it is 0 mod 2. Want to prove this part on your own or want hint?
I can try to prove.
Okay, sure, try to prove this one is 0 mod 2.
Could you give him?
Okay, sure. So, if you prove one of them is even, then the problem will be solved, right? At least one of them.
Oh.
Agreed?
Mm-hmm.
So let's prove first one is even, okay? Can you tell me alpha 1 is at most what?
Alpha 1 is at most raised to minus 1.
Exactly. So I want to prove if alpha 1 is at most this, then and alpha 1, do you agree we can say is at least what?
Is at least 1.
So I want to prove 2 to the m minus 1 plus alpha 1, choose 2 to the m minus 1, the first one is even, okay? I want to prove this. I want to prove this. If it is not equivalent to this, but if you prove this, this one will be solved, right?
Oh.
I want to prove it. So when we want to prove this one is even, we should do what?
V2 of the.
Exactly, V2 of
Okay.
this. So how can we calculate V2 of this? V2 of this one is what?
Is it like GIF of 2, like you do is it like GIF of 2 raised to n minus 1 plus alpha 1 over 2 raised to over 2, and then plus that.
At first, let me ask you this. V2 of n factorial is what?
GIF of n over 2 plus, GIF of n over 2 plus n over 4 plus n over 8, and so on.
Yes, and we can write it as sigma n over, for example, 2 to the s, or 2 to the t from 1 to infinity, right? And we call this formula what? Do you know the name of that?
No.
Legendre's formula, okay?
Okay.
Now we want to use this here. So let's write it first as factorial. It is what factorial over what factorial, what factorial?
2 raised to n minus 1 plus a1 factorial.
Yes.
A1 factorial times 2 raised to n minus 1.
Yes. Now do you agree by using this? We can say it is what? It is sigma what?
Sigma 2 raised to n minus 1 plus a1 over 2. Over 2 raised to k. Or 2 raised to t from t is 1 to infinite. And then minus a1 over a1 over 2 raised to t minus 2 raised to m minus 1 over 3.
Exactly. Okay. Do you agree for each t it is at least 0? Why for each t it is at least 0? So because what?
Is it just because for large t?
For any t. This one is at least 0. Try to prove this. Okay. Why for each t this part is at least 0. Okay.
Oh, is it because this is greater than or equal to 2 raised to n minus 1 over 2 raised to t plus j of a1 over 2 raised to t, and so it cancels out in that case?
Yeah, because you can say in this point x plus y is at least x plus y. Okay. This one is x, this one is y, this one is x plus y. Agreed?
Right.
Okay. So because it is always at least 0, do you agree if we find only for one t it is positive, then we can say it is positive and the problem will be solved?
Okay.
Okay, so want me to tell you for which t it is positive, or want to find it on your own?
I can try and find it.
Okay, sure.
Oh, so it becomes
Wait. Oh, it becomes 1 at t is m.
Exactly. As t is m, it is at least, it is 1, So if t is m, why it is 1?
Oh, because alpha 1 is between 1 and 2 raised to m minus 1. And so the two minuses become 0. And then the first part becomes, it's between two numerators between 2 raised to m and 2 raised to m plus 1 minus 1. Or minus 2, sorry. And so.
We know alpha 1, yes. We know alpha 1 is at most 2 to the m minus 1. So this one is 0, this one is 0, right? But because it is at least 1, this one is at least 1. We can prove it is exactly 1, right? But we can say in this part it is at least 1, right? Because it is 0. It is 0. And because alpha 1 is at least 1, it is at least 1. Agreed? Like the thing you said, you can check that. Is it exactly 1 or not? You can write inequality. If you write this, it will be 2 to the m plus 1 minus 2. And you can say it is exactly equal to 1, right? Okay, so we proved this problem completely now. Agreed? Because this one is 0, this one we proved, so this one is 0. So all the things here will be 0. So we proved that. Now let's see the problem again to answer exactly what it wants. Problem was what? Problem 4. Let me copy the problem. Control C. The problem said that this one. So if you want to answer this problem, it says let f of s be the set this, and for this n, how many subsets of this can be turned into 1? We proved what? We proved L of 2 to the 2 to the m for the first time. That the length changes is this one, and this was 2 to the m plus 1, right? So now that we proved all these things, if we want to answer this, answer of this problem will be what?
It's is it so it's gonna so is it just for x between 2 raised to 2 raised to m minus 1 and 2 raised to 2 raised to m? It's 2 raised to m?
For n, less than 2 to the m and greater than or equal 2 to the m minus 1, answer is what?
Answer is 2 to the m.
Exactly. We proved this, and so let's check only for the small examples. So, for example, if m is 1, it will be what?
If m is 1, it would be 1 and 4 between 2 and 4.
Yes, answer is what?
Answer is 2.
Yes, and it's correct. Because for 1, 2, 3, we know it is this one first, then it is this one, then it is this one again, right? For example, for M2, n is at least what?
For m2, n is at least 4 and less than or equal 16.
Answer is what here?
Answer is 4.
4. If m is 0, if you take m0, it will be from what to what? And because m is 0, do you agree? We can consider this part for m at least 1, okay? And m has at least 1, so you should only consider n what?
And
What is left? Look here, from n2 to 4, we considered all these answers. So 1n is left. So which n we should check that n separately?
is 1.
Yes, so for n is 1, answer is what?
1.
1. So for n1, answer is 1, and m greater than equal 1 covers n at least 2, right? And we found all answers, right? Like this. If you write, so you should write like this for these answers at the end, okay? Okay, understand completely how we solve this problem?
Yes.
Okay, it was a super hard problem, and we solved these with different methods, Legrange's formula, but the background idea of this one, the most useful idea here was considering a small example, right?
Right.
Because if we don't check a small example, we cannot understand these numbers are important, right?
Right.
But when we check a small example, we can see, okay, and 4 is important, 16 is important, and we can guess this idea, okay?